in and simply do the same calculations. And I just assign n2 to n and do exactly the same calculations. I copy this stuff here, and I'm highlighting. They're all copies of the same thing. It's all the same thing. I just assign in different values to n, and I just do the same actions. That is kind of a precursor or the first step before what you're going to see right now. And these are functions. And compare this one, 6 dummies with 7 functions, and you'll see what functions are going to do for you in the near future. I like to see how well we understand loops before I move into functions. But if you want, you can look up functions in the notes that I gave you. There's also very, very good stuff on functions on YouTube. Let's see. Let me see if I can make this a little bigger for you. Format. I think it's edit. I don't see it. There, let me see, options. Okay, there's no option to make this thing bigger. Is there a zoom down here that I can? No, there's not. A zoom meaning to increase the font size. Okay, I don't see that. But at any rate, you'll notice how much this looks like what I had in the previous file, except for now I create a function here. Where's the function definition? Oh, 1 second. Yeah, this is the function definition where it says def census in. In is called a parameter. Now, whenever you use a variable, this is kind of, we'll have to get to this maybe in a couple of weeks, but just to the complexity of this. There's things called local variables and global variables, and even something called block local variables, but we don't have to deal with those yet. Global variables are objects that are not defined in the function itself, but you have to tell Python that some variable that you use is not a local variable, or it'll get mixed up. So here I'm saying that inside count, outside count, and border count are defined somewhere outside the function. And here they are right here. And in, of course, is a parameter. Okay, I don't have any local variables in this thing. Well, as I say, when we get to functions formally, we'll go into more definitions more information about this. But we're getting to some complicated stuff that's called scope. Scope just means where a variable is defined, where you can use it. And so these guys are global variables because these guys right here are global variables because they're not inside of a function. And in is actually a local variable because it's declared as a parameter in this function. Kind of like I did last time. See when you invoke the thing, it says census in1. That's invoking the function, and that copies in1. This is called the argument. When you invoke the function, this thing is called an argument. Inside the function definition, it's called a parameter. And so Python copies in1 to in, and then you do all this stuff inside the function, and then you keep on doing it. It's very much like you saw in the programs in 6 dummies, where I have to do that, where I have to manually assign in1 to in and so on. And I have to repeat the code over and over again. If you go back and look at that file, you'll see what I'm talking about. Here, I just have to do it one time. I define the function and done. I simply keep using the function over and over again with different parameters. I hope I'm not talking too fast. Again, you can look this up in your, yes, does someone have a question?
Okay. Global was for the whole thing?
Global variables are variables that are not defined inside the function. So here's my function census. I have inside count, outside count, and border count. Their definition is not inside the function itself. The only variable local to the function is in, this guy up here. What global is telling the function and saying, don't look inside the function for the definition, look outside of the function. Go up one level outside the function. Now, it can be very, very complicated because it's possible to find functions inside of functions. And then when you make it look outside, you have to look outside to the function containing function. If it's not there, it looks outside to the, I guess, the program file itself. This stuff out here. And you can even make it, it gets more and more, it gets a lot more complicated than this, but just an idea of this complexity, the idea of scope. Right now, we just know about global scope and local scope. And in a couple of weeks, well, we have to do arrays and lists first. Then we have time. If we have time, we'll do functions. Technically speaking, in your Visual Basic class, in the 103 class that uses Visual Basic, you just have to get the while loops, or loops rather, which is what we're doing today. But I think you would like to go on and write some more complicated programs than just stop or just do loops for the rest of the next 4 or 5 weeks. Loops can be very interesting, but I don't think they're interesting for 4 weeks worth. And you might, as I said, arrays are very, very, you can write far more complicated programs than we're writing now once we understand arrays. And then once we understand functions, we can write very, very complicated programs. But I don't want to force something on you that, I don't want to add too much stuff to the class that wasn't really part of the original syllabus for our class. Like I said, we're really just supposed to get to loops. But if this is making sense to you, we can go further into lists and arrays, and then finally into functions. Anyway, having said that, if no one has any questions, I will move boldly on. Let me minimize this. Yes.
I think I have questions, but so where does it look at? Like, where does it look for the stuff? Like, is it just stuff above that, or is it like a space that doesn't exist, like a random place?
What it can do is you notice how you do let's scroll up here. Notice how you do import from random import a function. You see the import statement? You can write your own files, and you can import your own files into your program, and then it'll keep looking into the import stuff, into the imported files. So they're looking for looking for a variable or function can continue outside of your main program. So it just doesn't stop in the main. This is our main program up here, and so you can go since it's yes.
For example, like with machine learning, they blend data from the program itself and from external sources. Is that something?
Yes, that's what I'm saying. We're not going to get to that, but it's certainly possible to do that in Python.
May I ask a question, sir?
Yes.
What would be the highest level of math if one was to take this course during the summer?
The highest level of math?
That one needs to,
Well, arithmetic, I hope I haven't given you any complicated mathematics. We're just going to do ordinary arithmetic. So I guess I think of that's math 124, which is the beginning of algebra. I'm not sure. You just need arithmetic, really. Add, subtract, multiply, divide.
Well, I mean, there's a lot of logic functions involved, I can tell.
Oh, yes. Okay.
So, I was considering taking this course in the summer.
I think the class is supposed to teach the logic that you need to write the programs.
Oh, I see.
We started off with just simple. I mean, the first conditions we had were the first if statements we had were one-way if statements, and those conditions inside the one-way if statement were simple expressions using the relational operators. Less than those guys. And then we got a little more complicated by adding the logical operators and, or, and not. So I don't know if this is going too fast, we can go more slowly so you can absorb the concepts of the logical operators and the logical operators and how they relate to how they're connected to the relational operators. They don't teach that in in the math department, if you wanted to, the philosophy department has classes in beginning logic. This is first order. We're learning something that's called first order logic. And you go over the relational operators and the logical operators and De Morgan's laws. They also have that in the mathematics for programmers course. But I don't think that I'm not trying to make the logic too more difficult than it's been. I mean, I'm not trying to make it really complicated logic. It's just, like I said, the ands, ors, and nots, and you won't be combining very complicated expressions. You're going to do one of your only one classwork assignment. The one classwork assignment for tonight could be done using a compound condition with either an ors or ands, but there's ways to get around those, which we'll, I guess, discuss soon enough. So
Okay.
I think, well, tell me what you think of today night's classwork. It's going to come around on board about 8:50, and you'll have until Sunday to complete it. So see how hard you think that one is, how hard you think that is, and that might help you determine what math you think you need. But logic, they don't really teach logic in the math department. They don't teach formal logic in the math department in the sense of defining, going through truth tables and De Morgan's laws and the translation of statements written in English into formal logic. That's done in the philosophy department more than anything else. Because I don't have a logic textbook with me right now. I mean, I have one downstairs, but if you want, I can show you what kind of problems you'll have in logic. Anyway, so but we're going to go on right now. So this is the function part, and I've introduced a little more complexity than I should have. We're not going to do anything more than global variables, and. Okay, so on we go. Let's see. All right, this is what we're going to be talking about today. Let me look at this for a moment. Oh, okay, functions, arithmetic operators. Let me see. I might have deleted the arithmetic operators from this thing. I did. Oh, well. Yeah, okay, I think they might be in this file. Let's see here. Okay. Ah, there they are. These are ones you already know. Addition, let me make this bigger so I can see it.
Can you explain the percentage one again?
I will explain that in just a moment. Addition, subtraction, multiplication, division. The percent side is called the remainder operator, and that simply gives you the remainder. So if you did something like this, I'm gonna just create a new file. Let me just give you an example. So if you said n equals 5 and m equals 17, and then let's see, mn p equals m modulo 5. Okay, the value of p is going to be 2, because when you divide 17 by 5, the remainder is 2. It's called the remainder operator. Oh, I'm sorry, I didn't mean to do it that way here. Once again. There. Yeah, the value of p is 2. If you did this, q, that's not q, of course. Q equals,
only the remainder, not anything else.
I beg your pardon?
So it's the amount remaining and not like other, it's not like 2 remainder 1, or it's like just the remainder part.
It's just the remainder part. That's why I said p is equal to 2. P is equal to 2. There's nothing else in there. It's not. Some computer languages, when you do this, will return, I think, the quotient and the remainder. But I don't think what is this language? I don't think Python does that, but we can look it up. And if you do this, if you divide 5 by 17, the remainder is 5. So that's what that thing means. Another thing, some of you were doing this all the time. So if I did n equals 5, and then you do m equals int n. You don't have to do that. N is already an integer, so when you assign n to m is going to be an integer. So you only have to if n is a string. If you input in, if you do n equals input blah blah blah, and then n is read as a string, then if you want it to be an integer, you have to use the conversion operator int. But if something is already an integer, you don't have to convert it again to an integer.
Does that also apply to if it's if you're asking for a number? For example, if you're asking them to enter a number, do you have to turn it into an integer, or because they actually push enter an integer, it's already assumed that it's an integer?
No, it's not. Remember, when you use your input function, it always returns a string. Always, everything, it's a string. Every input returns a string. If you do, r equals input, enter a number, like that. R is going to be a string. It's always going to be a string. Every time you do an input, it's going to be a string. If you want to get fancy, which I try to avoid doing, you can always do this. And that'll work. And then R will be an integer. But I've just did it using 2 steps rather than just do it all at once. But you're free to do it this way if you wish. S equals input, enter a number, and then S equals int S, like this. So there's the 2 ways that you can read things, and you can do it. The first way, which is a little more complicated, which is fine, but I like to just put all the steps right out there so I can see them rather than be clever. Which you can be clever as much as you want, but the main thing is not to be clever, but to make your programs easier to understand. You're not trying to make it hard for people to understand your program. You want it to be as easy as possible for people to understand your program.
I have a question.
Yes.
So if you had as input a string like you have right here with enter a number, and you try to convert that into an integer, that wouldn't, I guess, logically make sense. But if your input were an integer already, you're saying that whatever is defined inside the parentheses of the input would still be read as a string, even if it's an integer?
Yes.
Okay.
It stores all your input. No matter what you do, whatever you type into the keyboard is stored as a string.
Got it.
Then you have to convert the string to an integer if you can. If you type X, Y, Z, and you try to convert that to an integer, you get a runtime error. If you type in 1.475, 1.475, and you try to convert that to an integer, you'll get 1 because they chop off the decimal fraction part.
Right. Okay.
Other questions?
And then
Yes.
you use float to allow decimals and
I beg
negatives,
your pardon?
right?
Say that again?
And if you use float, you're all allowed to use decimals with that.
I'm sorry, please say that one more time.
And if you use float,
yes.
can you hear me?
Yes, I can hear you now.
You can use decimals with float.
You're cutting out, Randy.
They're cutting out also. You can use decimals with that.
I can use what with that?
You can use decimals with float.
Yes, floats means it's a decimal fraction. Yes, floats are how you use, that's when you want to use a decimal fraction. That's where you want to have stuff to the right of the decimal place. Floats are, that's it's called floating point numbers because you have a decimal point. Integers don't have decimal points. Floats do. So, yes. So if you did something like this, If you did n equals, well, let me go down here a little bit. All right, so I did n equals 3 and m equals float 3. Then m is going to be stored as 3. I mean, m, the value of m is going to be 3.0 because just tack on a decimal place there. Even though n is 3, it's going to give you, oh, I'm sorry, my mistake. I should have typed this. Well, it doesn't matter. It's the same thing. But there. Now, thing you realize is that this m, when you type m equals float, open parentheses, blah, blah, blah thing there, it's not going to change n. It only gives you a floating point value of, m is a floating point representation of n, but n itself doesn't change. It's still an integer. Okay. Other questions on that one? Okay, on we ever on. I'm going to just go through this sort of technical stuff about loops then, and we're going to get into some examples. All right, so let me see if I should have deleted one in a moment. Oh my God. 1 second. Okay, yes. All right, I moved this to another part of the file, and I should have deleted. Anyway, okay, loops. Loops consists of about 4 or 5 components. Let me go over them right now. There's the body of the loop. Okay, well, first of all, what is a loop? It's a structure that repeats a collection of statements over and over and over. You can just do this stuff over and over and over forever if you have to. Like chopping up a potato. You start at one end and you keep chopping until you get to the other end of the potato when you're done. Loops are the same thing. You start at the beginning and keep on going until the loop ends, or perhaps the loop never ends because either you don't want it to, or you made a mistake. An example of a loop that doesn't end is the scheduling loop on your operating system. It keeps trying to schedule a new function or a new process, and if it can't find a process to schedule, it schedules something called the idle process, which just sits there and does nothing. I'm not going to show you my task manager, but that's just an example of a loop. Mostly loops are designed to end. There's something called, so the body of the loop of the statements that you repeat over and over again. I'll show you some examples of this very quickly. I'm just getting some definitions out of the way. And there's something called the loop condition. And if the loop condition is true, the body of the loop executes. If the loop condition is false, the loop, oh God, it should be the loop stops executing. The loop stops executing. There we go. Yes. So the loop condition is kind of like the gatekeeper. If the loop condition is initially false, then the loop doesn't execute and you're done with it. If the loop condition is true, then you execute the body of the loop. Now, there has to be something in the body of the loop that will change the loop condition. Otherwise, the loop's not going to end. Again, theoretical stuff. You'll see some concrete examples in just a moment. The loop control variables. The loop condition is a function of the loop control variables. There has to be something in the body of the loop that will change the loop control variables so the loop will eventually end. Loop initialization. Before the body of the loop executes, the program assigns, that should be assigns, initial values to the loop control variables and other variables. Loop finalization. Some loops don't have a finalization part, but a lot of times the loop is calculating something. And so the results of the calculation appear or are used in the finalization part. That's what happens after the loop ends. Fortunately, in your program, in your classwork assignment, you're going to have a loop finalization part. And then test after loops. we're not going to do any test after loops tonight, but a test after loop, it executes at least one time. Oh my God. I don't have it. Where's my thing on a test first loop? Oh, I must have deleted something. Okay. I'm not sure what I did there. There's also something called a test first loop. Test first loops. The loop condition may be false and the body loop condition may, where is that? May be false initially and the body of the loop does not execute even once. And test after loops, the loop condition tests after you test the loop condition to see if it's true or false after the body of the loop executes one time. So test first loops may not execute at all. The body of a test first loop may not execute at all, but the body of a test after loop executes at least once. We'll just be doing test first loops tonight, so don't get upset.
Go back to loop condition.
Yes.
See how you change that, please.
The loop condition is a function of something called the loop control variables. The body of the loop has to change the loop control variables in order for the loop condition to change from true to false, so the loop will eventually end. All this is very abstract. I'm going to show you some loop condition. Okay. Did that answer your question?
Yeah, I just wanted to see, so you took out condition, the loop condition from executing. It's just the loop that stops executing.
If the loop condition is false, the loop stops executing. Yeah. Well, no, yes, the loop. Okay. Yes, you do evaluate the loop condition every time the body of the loop executes. So see, in a test first loop, you assign initial values to all the loop control variables in the loop initialization part. Then you test to see if the loop condition is true or false. Again, the loop condition is a function of the loop control variables. Then, if the loop condition is true, you execute the body of the loop. Now, the body of the loop is going to change at some point the loop control variables, so the loop condition will become false. See, the body of the loop executes while the loop condition is true. And unless you change the loop control variables, the loop condition will always be true and the loop will never end, which is not something you want usually. So there has to be something, the loop control variable, at least one loop control variable must be calculated or recalculated in the body of the loop, so the loop will eventually end. Okay. I think we better get to some examples very quickly. All right, I think that is okay. Test after loops. Okay, if the loop condition is true, the body loop executes at least once more. That should be once more. Okay, let's see, okay. Okay, for loops are a lot easier than while loops if we're done with while loops. Actually, in the beginning, many years ago, they didn't have for loops. They just had while loops. And but they found that certain kinds of loops had sort of a similar structure. And they said, let's create a while loop. A for loop is a specialized version of a while loop, in that it simply starts at the beginning and goes on and just, let's see, it's called a counting loop. It simply executes a fixed number of times. A while loop, you don't really know how many times the while loop is going to end. But a for loop always executes or is designed to execute the same number of times. You can get out of a for loop or a while loop before it finishes executing. but unlike a while loop, a for loop is designed to execute a fixed number of times. Now you can defeat that design by breaking out of the for loop. You can also break out of a while loop for that matter. But it's as I say, its design is to execute a certain number of times. Okay. All right. So this is what the different ways a for loop looks like. So this is for n in C1 through CK. So unless you do something, I know this is kind of abstract still. For n in C1 through CK, do the by the loop. So this loop is going to execute k times because there's k things in that range, C1 through CK. Yeah, it's going to now C times. Now, this one is a little bit more sophisticated. It says for n in the range, lower bound to upper bound. Now, assuming lower bound and upper bound are numbers, they don't have to be. Let's say lower bound is 1, or it's 5, and upper bound is 10. What's going to happen is it's going to execute upper bound minus lower bound plus one number of terms. So if lower bound is 5, wait, no. If lower bound is 5, okay, I made a mistake. If lower bound is 5 and upper bound is 10, it's going to execute 10 minus 5 or 5 times. So with a for loop, you always know how many times the thing is going to execute, or theoretically is going to execute. Ordinarily, did I spell ordinarily? I spelled ordinarily wrong, actually. Ordinarily, I think that's correct. Ordinarily, the for increases n by 1, but you can change this. So it starts out at, let's say lower bound is 5. So lower bound is 5, it executes body. Then lower bound is 6, it executes body. Lower bound is 7, executes body. Lower bound is 8, executes body. Lower bound is 9, executes body. Now, when lower bound is 10, it doesn't execute it. Lower bound is 5, upper bound is 10, but it only executes it for, lower bound is not changing, upper bound is not changing. It creates a loop control variable that you don't see. And it executes a loop control variable from lower bound to upper bound minus 1. Well, I'm sorry. I'm so stupid. No, it's n. N is the, I guess you could call it the loop counter. And so the value, go on, I'm sorry. The value of n starts out at lower bound. Every time you execute the by the loop, you add 1 to n. Now, when n is the last time that the body is going to execute is when n equals upper bound minus 1. When n equals upper bound, the thing stops executing. Okay. Ordinarily, we're going to, I guess, I have a bunch of examples that I'm going to show. Let's see. That I'm going to show you. Right now, I just want to get through the theory part, and we'll sort of the general explanation of how these things work. But so this is exactly what it looks like for n in range, lower bound to upper bound. And what range is a function that simply transforms this thing into a loop like this. So yeah, see, you really only have this kind of loop. And the range function simply transforms this range lower bound to upper bound into something that looks like this. Okay, and I forgot to put the colon here. There should be a colon there. There should be a colon. In case you were wondering why I didn't have one, that's why. Okay. Okay, so that's a for loop, but again, it's simply, you always know how many times a for loop is supposed to execute. You may not know how many times a while loop is going to execute. All right. Okay. So ordinarily, the for, I should have written the for loop. Should have written loop there. The for loop increases n by 1, but you can change this by adding a step parameter. or a step value. So you could write for in range, lower bound, upper bound, comma, step by. Ordinarily, step by, I mean, if you don't put step by in, its value is going to be 1. But you can make it step by 2, by 3, and so on. Meaning you add instead of adding 1 to in each time you go through the loop, you could add 2 to in, or 3, or so on. So you don't have to go just one at a time. How do you make the? I should have put a question mark there. We're going to look at that in a bit, or we'll look at it next week. You can research this if you want. How do you make it step from a lower value to an upper value? I mean, from a higher value down to a lower value. Sometimes, let's say you want to write a program that displays the lyrics of 99 bottles of beer on the wall. 99 bottles of beer on the wall, 99 bottles of beer, take one down and pass it around, 98 bottles of beer on the wall. So that's going from 99 down to 1. So how would you write a loop to do that? That's another for loop, by the way, because you start out at 99 and you stop at 1. So the question is, how do you make a loop step down rather than step up? And again, trying to find the question mark.
Should there be a colon after step by in the line above that?
Yes, there should be, yes. There should indeed be. Let me see, I'm trying to find, there's a colon right there. Good. Yes, there should be a colon there. Yeah, those those block terminators, I just have to remember them. And the nice thing is about that your Python compiler will tell you quite dramatically that you've made a mistake, you forgot to put that in there. But all these block things like if statements, fors, and whiles, they all have this, it's actually more of a block initialization. It's just saying where the block of your stuff starts. Anyway, okay, so I beat those to death. All right, while loops. Okay, good, we're done. While loop repeats the statements in the loop's body while the loop condition is true, or repeats the statements in the body until the loop condition is false. I just said the same thing in 2 different ways. Something in the loop's initialization or in the loop's lopos. Let's fix that one. In the loop's body must change at least one loop control variable in order for the loop to end. Okay, let me save this thing and we'll start looking at some examples, and we'll write a few programs and have some discussion about that. Okay, let's see. I think and here's the programs we're going to write. Wait, I might have, let me see. Oh, I don't have any examples. What did I do with the examples? Oh, I guess we're just going to write them all. I thought I had a few examples in here, but that is not to be. Okay, let's look at this thing. And this is what we're about to do, I hope. Uh-oh, I hope so. Ah, there we go, good. Good, I have 8 examples that we're going to write here. All right, program 1, reads a number in from the keyboard, adds numbers from 1 to n and displays a sum, and compares the sum to the formula n times n plus 1 divided by 2. That's the formula for counting the sum of n consecutive integers, starting at 1. And so we're going to test this formula by what? By reading in from the user and knocking it out from there. Okay, so that's the first one. Let's grab this guy and start writing Python. Copy. Another thing. Okay, let me just get Python up here. Show desktop. Okay. All right, let me go in the Python editor. Excuse me. Let's get rid of this stuff. Okay, so another thing you can do this, paste. And so I'll just put here, make these guys comments, 1. And I'll just, I'll translate the comments to Python, 2, 3. Okay. All right, so let's do that. Okay, so now what I want to do is I want to read in from a keyboard. And so I'll do my prompt. Prompt equals, yes, sorry.
What time is this?
Once more.
What time is this?
This is not an assignment. These
Hello?
are examples I'm doing for you so you can do the classwork assignment. So I wanted you to have the luxury of just watching this and trying to understand what's going on. So we're going to do a for loop in just a moment. Enter a positive integer like this. And I just do n equals, let's do it this, okay, n equals input prompt. Now, this is called called stepwise integration. So I'm going to do this one little piece at a time. I just want to see, oh my God. Let's see. So I'm going to run the thing. Oh, I'm sorry, I'm not in Python. Hold on. File, save. I'll close this up. And I think this is the one I just did. Oh, there's one of my, okay, fine, whatever. Okay. Okay, good. So now I can just run it. Run. And there it is. Please enter a positive integer. I'll type in 20. And there we got it. So that this part at least works. Okay. Now, however, let's be, okay. Another thing you want to do is, what do you want to do? Okay. N equals int n. I could test this to make sure it's a positive integer, but why do that? Okay, so let's see. Now I'll do this. I'll create another variable called sum because I want to add all these guys up. So I just write, I'm sorry, sum equals 0. All right, for, what should I call it? K in 1 comma n. It is like sum plus equals k. And let's see, so that, oh, yeah, see, I'm always going to forget this. I'm always going to forget that. Yeah, I hope I am. That, I just don't like K, but I'm just stuck with it. I don't want to change this any more than I have to.
The plus equals. Can you explain that again?
Shortcut. It's a shortcut. I'm sorry. It's just this. It just means sum. I'm sorry. Sum equals sum plus K. I apologize. I forgot they hadn't gone over those kinds of things. That's all it is. It's called in general syntactic sugar because it makes your program sweeter, or at least a little easier to understand. But that's all it is. There's a lot of them. There's a formal name for that, which I, for some reason, can't remember right off the top of my head. But I'll try not to use those. Okay, let's run this guy and see what we get. Try 5. Oh, that's because I didn't print the sum. That was pretty clever. Okay, so let's just go down here and I'll just write, give me some print sum. I'm not going to try to do any fancy formatting. Let's see. Oopsie, let's save this thing. And enter positive number 5.
You typed 5, but it entered 6.
No, I typed 5.
Oh,
That's
okay.
what it's supposed to be. Now, you're probably wondering what went wrong. what happened, remember, it only here, let me put this up here. See, it doesn't include n. So you want to sum the numbers from 1 to n, you have to make it go from 1 to n plus 1, because the k thing stops. All right, I did not give an initial value. Okay, good. All right, let's try her again. Here's number. Oops, let's try 5. Sorry, 5. Keep putting 6. 5. Uh-oh, why are we getting that? For K, let me see. That's actually incorrect. For K in 1, plus 1, so how can we get 7 for this? That I don't get.
Adding to 1 twice?
Hmm?
Is it adding 1 twice?
No, it's not. Well, I don't know. Let's see. It should say the sum of the first. I typed in the first. Okay. The sum of the first 5 integers should be 10. 1 plus 2 is 3, plus 4 is 7. 1 plus 2 is 3, plus 3 is 6. It should be 15, but I'm getting 7. So I don't know why why this is not working the way it should be. Let me just look at this. Oh, 1 second. That's another program. I just want to see what I'm doing wrong here. No, that didn't do that. What? I should have some. Huh. Wow, that's pretty sad. Let's do this. We can see what's going on by looking at the values of k.
If you put in 1 comma n plus 0, it prints 6.
1 comma n plus 0? Yeah, well, that's true.
The line above where you are.
Yes. Let's see what we get when we do this. All right, so let's run this again. Five. Oh, the only numbers I get are 1 and 5. Oh my God.
And 6.
Well, 6 is a sum. That's actually. Oh my God. I'm so sorry. I forgot the most important point. Range. The range function. See, let's go back to this. Without the range function, the only thing it prints are 1 and n. When I put the range function in there, then it'll give me the range of numbers from 1 to n. Okay. Sorry, spelled range wrong. Wow, I couldn't understand what was going wrong there. Let's try it again. Wow, we entered positive number 5. Yeah, okay. So that's actually, it's giving the sum of the numbers from 1 to 4. If I want the sum of the numbers from 1 to 5, I've got to do this. See, it's always 1 less than the second. The range is always 1 less than the second parameter. Okay, I can tell. Okay, so thank goodness. Now I know it went wrong. That was kind of frightening for a moment. But yes, I missed the range parameter. Okay, that's just equivalent to this thing. Well, let's calculate this then. I'll put f sum equals n times n plus 1 divided by 2. And I'll just print f sum. They should be the same. Let's try this one more time. And let's see, if we try 10, see 10 times 11 is 100, so we should get 55. All right, so here we go, 10. And we got 55. The reason I'm getting the 0 there is because every time you do division, Python assumes that you're going to get a decimal fraction. I could have converted this to an integer, but who cares? least we know the thing is working, and we have now got a little object lesson in how not to use the range function, or to use the range function. I
Can you walk us through what we just did?
walk us through how this works.
Like,
Sure.
Like, what is it doing? Like, what's it doing?
Well, say that one more
So,
time.
like, what's the program doing?
It's
Like,
adding up
taking
the
a
sum of the.
number-
This is what the program is doing. It's adding up the integers from 1 to n. So if I type in 5, the answer is going to be 15, because the sum of the integers from 1 to 5 is 15. Now, we can do this in two different ways. We can generate
hold on.
integers from 1
So
to n, right here. I'm sorry.
So, like, 1 to n, or from 1 to n? From
1
n to
n.
1.
1 to n.
Math class, I learned n is like from 1 to n. That doesn't make sense to me, because like 1 to n be like nothing. There's nothing between n and 1.
Well, I'm sorry. Let me explain to you what I mean. Let's say that you want to add the numbers from 1 to n, where n is 5. You're going to be 1 plus 2 plus 3 plus 4 plus 5. That's the sum of the integers from 1 to 5. And
So in that case, n is
5. The sum of the integers from 1 to 5
okay.
is 1 plus 2 plus 3 plus 4 plus 5.
Okay.
Okay, well, so we're doing that two different ways. One is using a loop. That's the first way. The second way is using the formula and calculating f sum. We get the same answer. Actually, I'll do it this way. I can just do int like this and convert the thing from a float to a number, to an integer. And so now we should get the same result. Okay, so you have 55. Oh, wait a second. You have 55, and up here, 50. Oh my God, why am I getting the same thing?
You haven't actually entered the positive integer yet. The prompt at the very bottom.
Oh, thank you. Thank you. Okay, let's try it one more time. 5. Oh, okay, now we get 15 by adding the numbers up and 15 by calculating our formula. So there, that's a simple for loop. I can do this with a while loop as well. And just to show you that they're equivalent, let me do that. I'll do, this is a little bit more complicated. So k equal 1, while k is less than or equal to n, like this, and I'll put, let's see. I got to put sum back to 0. Sum equals 0. And I just put sum equals sum plus k. K equals k plus, oopsie, that's not good. K plus 1. Now, let me think about this. All right, when k is equal to n, I add k to sum, and I add 1. Yeah, it's gonna end. Okay, so I'll just do print sum again. Okay, so I should get the same answer for everything. But let's look at this. Let's look at the while loop structure again. Yes. Once more.
Why do you let sum equal 0?
Because I have to recalculate sum. See, if I didn't set sum back to 0 again, I would be adding what the previous value of sum was. See, I'm using sum up here, and I keep adding k to sum, and sum is a number now. Well, this sum here and this sum up here are the same sum. So I have to reset it to 0. If I don't, let's try it with 5. If I don't do that, okay, so I type in 5. And you'll notice this time I get 30 for sum. My last sum printed out 30. That's because the value of sum was 15. I just added 15 to it again. See the last number down here is 30? That's this sum right here. So I have to set the thing back to 0. Sum, oopsie, yeah, sum equals 0. And this time if I run it, I should get 15 all the way through. Yeah, so this time I got 3 15s. The last time, if you recall, I had 15, 15, and 30. That's because I didn't reset sum's value back to 0. Again, these are like little boxes. So once I put 15 in my box, it's going to stay there until I remove it or change it. So because I didn't set 15 back to 0, sum back to 0, its value was still 15, and I just kept adding more and more stuff to 15. Any questions about that one? Okay. All right. So yeah. I'm sorry.
I have a question. So it says while k less than equal to n,
Yes.
then sum equals sum plus k, and so that's 1. So
K,
sum plus 1.
Yes, k equals k plus
and then
1.
and then k equals k plus 1. What does that last part mean? Like,
you mean k equals k plus 1? What does that mean?
yeah.
Okay.
Is that like k will equal 1, k will equal 2, k will equal 3?
Yes.
Okay.
Okay. Any other questions? Okay. Let's save this because I want to send this to you after class. I'm going to save this as, okay, we'll call this, oh no, that's actually the program we're writing. So this is going to be program 1. Program 1. Let me see, let's get that out of my desktop and get it to your stuff. Let's see, where is that? Okay, and I'll upload this after class. Okay. All right, there we go. Okay, good. All right, so we're done with this guy. Let's see what the next one is. And this says, running on a particular treadmill, you burn 3.6 calories per minute. Write a program that uses a loop to display the number of calories after 5, 10, 15, 25, 30 minutes. This is going to be a for loop because I know exactly how many times I'm going to do this. Oh, yes, so I know exactly how many times I'm going to do this. Okay, let me grab this stuff here again. I'm just going to translate these comments into Python code. So let's see, let's go back to our thing here. Show desktop. Okay, so I'll open this up. All right, so I think we already made a copy of this. Good. Good, all right, so that's that. So I'll paste this in here. Oopsie. I might be missing something. Oh, no, I'm not. All right, so there we go. Okay. Running on a particular treadmill, you burn 3.6 calories per minute. Write a program that uses a loop to display the number of calories burned after, okay, so on. Okay, so this, all right, so I'm going to do this in 2 different ways. The good way and the bad way. The good, the bad, and the non-compiling. All right, so here we go. One of the things you might want to avoid doing, well, I'll get to that later. Okay, well, one thing you do is you'd want to avoid, if you can, using literal constants in your program. So I'll just call this cal burn rate, or burn rate, for example. Burn rate equals 3.6, like that. So that's why if these are rather simple programs, so it doesn't make that big a difference. Okay, so now I'm going to put, let's see. let's see, it's 3.6 calories per minute. See how can I do this? Okay. For calories. Let's see what's the best way to do this. Okay, it's minutes. For minutes in range 5,30, 5,30,5. Oh, finally I get to show that. I see, and let me think. I might have to make this 35 because I only want to go up to 30, or 31. Maybe 31 would work. Maybe 31 will work. But what's happening is I'm incrementing minutes. A minute starts out at 5, and every time I go through the loop, I add 5 to minutes. That's what this thing up here is for. So this is my increment value. All right, so, okay, so here we go. Sorry, let's just do this. How do you spell it? Initial val equals 5. Final val equals 30. And increment equals 5. Okay, so I'm going to knock all these guys out. And so instead, this is what you want to try to do. It makes it easier to change your program for range in init val, comma, final val. Let's try to call it fin val to be consistent. Fini val. Let's see. I know this is a foolish consistency is a hobgoblin of small minds. Okay, so this is a foolish consistency. Any val, fin val, and I'll call this step val. So I'll change this back to step val. You do this because you want your programs to be easily understood. You'll understand your program. So I'll make this final val plus 1. So that I think I'll be able to get in my last thing. See, remember, it stops at 1 less than final value. So I'm going to make it stop at final value by writing in final val plus 1. And we'll see how that works.
What is the significance of the particular order? Like, I would have understood it if it was, initial value and then final value plus 1. Why does the step value go last here in the order?
Because by default, by default, the first 2 parameters of range are the initial value of the range and the final value of the range. And the third value is the increment value.
Is that always the case for for loops?
Yes.
Okay.
You can leave off the step value, but except for that, yes. And you can have more sophisticated, it's actually not for loops. What you're really looking at is what range does. Range is actually a function. What range does, it delivers. See, when I execute the range function, I'm not absolutely sure it's going to be exactly like this, but I'll have. So what range will do, what the range function will do is we'll replace this with 4 minutes in equal 5, 10, 15, 20, 25, 30, and then I think 31. I'm not sure. It should go up to 30 and then stop. So the range function simply replaces this stuff with this. If you remember
Right.
the original value I showed you.
And you're just dividing, you're not dividing, but you are determining with that last value the differences of numbers between that range. I don't think I'm saying that correctly.
I'm determining how minutes changes.
Right.
So yes, step val changes what I add to minutes. Now, as I said, I'm not sure about final value. We're going to see if we can get in the 30 or not. I'm not exactly sure, but we shall see in just a moment as we do this. All right, so we'll just do let's see, how's the easiest way to do this? Oh, calories. Okay, so
we need to have a colon.
I'm sorry?
Do we need a colon after step val?
Yes, we do. Yes, we always need a colon. I'm always going to forget that, so thank you for reminding me that I'm accustomed to something called free format languages, where you don't have to put these things like this in there, or freer format languages in this one. I'll show you. Well, anyway. Okay, so, all right. So what we have to figure out is, see, what we don't want to do is we don't want to multiply stuff. What I want to do is just add something to the original value of calories. So I'm going to just put calories, calories equals the burn rate. No, equals an eval times burn rate. Because it's saying I'm going to display how many calories I've done. Actually, I don't have to do that. Well, okay, we'll just do it that way.
You should take the T out of eval.
Okay, thank you. All right. So we're trying to do the calculations as simple as possible. Addition is much simpler than multiplication. So I'm trying to do. Okay. One moment. I'm gonna have to pause for a moment. I'll be back at 7. It's 8 o'clock. I'll be back in 10 minutes. All right, we're back. Filling back. All right, where were we? Oh, yes. All right, what we're trying to do, if there's a simple way, let's see. All right, so that's calories equals a net calories by burn rate. Okay, so that would call that delta calories. I'll explain why in a moment. Delta cals. I need to type a lot. And I don't know if you can do an extended assignment statement. Let's see. Can we do an extended assignment statement like that? But what you want to do is say, let's do print minutes, comma cals. We just say cals equals cals plus delta cals. So our calories are going to increase this much every 5 minutes. So that should give us the result we want. Anyway, so I was trying to avoid doing, I want to do everything with addition. I didn't want to do multiplication do multiplication. So that's that thing. Oh, yeah, minutes, okay. So let's see if it gives us our last value. Our final value should be, let's see, it's 3.6 calories per minute. So after 30 minutes, that should be about 90 calories or 108 calories, I guess. So let's see what we get. So run the thing, hope it works, and away we go. And that is not good. Delta cals is not defined. I think I have a spelling error.
No, I think it's not letting you do the 2 equals.
Okay.
Oh, no, you have a capital C in the second instance of delta cals.
All right, great. I think you're right. Yeah, I think that should do it. Okay, let's see what we get. Visual Basic, by the way, is not case sensitive. All right, 108. It did work. It worked. So the thing that worked was this thing right here. Where is it? Yeah, this thing right here that made it go past 30 minutes. Watch, let's take this out. Let's take out the +1 and run it again.
So is that +1, that's not referring to an integer value so much as saying like the next in line after that final value, essentially? Like the next, I don't know.
Wait.
Yeah.
For loop is saying that. It's actually, I'll tell you what I'll do. I'll write this as a while loop in just a second. What it's saying, let's put the +1 back there. What it's doing is it's saying that I'm going to keep doing this while minutes is less than this expression fin_val +1. So since, let's see, fin_val is 30, so it's saying I'm going to keep adding 5 to minutes while minutes is less than 31.
I guess, I'm sorry, go ahead.
No, that's all I was going to say. What was your question again?
Well, so that's what I was referring to in that when we look at that +1, the 1 is not like the number 1. It's more of the next in place after that final value.
No, it is the number 1.
Oh.
It simply say it's going to keep doing that while range is less than 31.
Oh, I see.
Now, if I took it off, if I took the +1 off, it would say I'm going to keep doing it while minutes is less than 30.
Right. Well,
So,
like, for example, if you had put final value +4,
yeah,
and that step value is still 5, so that would still get you the same answer, right?
Yes.
Okay.
Yes. If I put -1, I get a much different, well, -1 would still give me, it would still go up to 25. Let's run it. Let's make sure this gives us the right answer again. Let's look here. Yeah, 108. You see, it goes up to 30.
Right.
That's what we want. Okay, let's do this with a while loop now. Did someone have a
Why
question?
does calories equal? I do.
But yes.
Why do calories equal calories and initial value? Or why delta calories equal calories?
You mean this thing, right? This is called a compound assignment statement. This, you're talking about this line up here, cals equals delta cals, this line.
Yeah.
Okay. So the way you do a compound assignment statement is you evaluate it from right to left. So the first thing it does is it calculates the value, init val times burn rate. Then it assigns that value to delta cals. Then it assigns the value of delta cals to cals. So on the far right side, yeah, you just keep assigning the thing from right to left. So first you calculate your if you calculate your value, you assign that to delta cals. You then assign the value of delta cals to cals. I could have just written it this way. I could have just said cals equals delta cals like this. I could have done that. That would have been just, that would have given the same effect. And I should have done that. Okay, that's a little less confusing. So you first evaluate. Sorry.
I still don't understand that. I don't understand why we have ever using two there or two, like, why we're assigning it the same value to two names.
Because the cals keeps changing. Delta cals doesn't change. So your first of all, you print the calories out and then you add to a delta cals. That's because you're changing every you're calculating how many calories a person has burned every 5 minutes. So the amount of calories that you burned in 5 minutes is 5 times the burn rate. So you're burning 3.6 calories per minute. A net cal val is 5. And so this is a net val. See, here's what's happening. See, your step value is 5 and your initial value is 5. That's why that works out that way.
So can you say that last part again? Which is the constant and which is the changing? Is it delta cals? So delta cals is the one that's going to consistently be changing in relation to the loop.
No, delta cals doesn't change.
Oh, okay. So cals is the one that changed. Okay.
Yes. Once you give init vals and init vals and any val, init vals and final vals don't change. Step value doesn't change. Delta cals doesn't change. The only thing that changes is cals.
So I'm sorry, go ahead.
No, I'm fine.
I'm just trying not to interrupt you because Zoom is not like it'll just cut off all sound if people talk at the same time.
Oh.
So, okay. So my question then is, if we've established that delta cals is a constant, step value is a constant, final value is a constant, initial value is a constant, burn rate is an integer, right? They're all kind of standalone things. What is the part in this for loop, I don't want to say equation, but in this function that tells us to, I don't know what I'm trying to say here. So I understand up until the point where it says print, right? So it's telling you print on the same line, the minutes, and then the corresponding calories that are going to change each time. So what is it in this for loop that says the calories are changing in relation to the function that we've determined?
This part right here.
Okay, so can you break that down into why initially we are saying cals equal delta cals, and then why we are adding delta cals to cals to get the changing numbers in cals?
Sure. They might see that you're starting this at 5 minutes. So after 5 minutes, the person has burned, 18 calories. But see, you're starting at 5 minutes. So the first time you print something, minutes is 5, and you burned 18 calories.
Right.
Then, so that's the initial time you go through. Then you want to know how many calories have you burned in the next 5 minutes. That's what delta calories is. Delta calories is the number of calories that you burn every 5 minutes. Okay. Now that's why I said it might have been better if I'd written it like this. Step val. Because step val is the number of minutes you're going every 5 minutes. So every 5 minutes you're burning 18 calories. So the number of calories that you have burned increases by 18 every 5 minutes. So after the first time you go through there, so you start off at 5 minutes. So after the first 5 minutes, you burn 18 calories. Next 5 minutes, you burn 18 more calories. You burn a total of 36 calories. Then 18 more, yes, 54 calories, yes.
Could you do the first line, like 5 and 18, and explain the computer's logic and how it, like, I understand in my head completely at every one of these numbers, but I want to know the equation, the words it's using, and how it gets that. Like, because I would get that. It's so not what I'm seeing. Like, I'm calories plus delta calories. Like, I don't delta calories, the difference of calories before from last time to the current time. Like, can you explain that? Like, just one line, like how it goes through, like 5, initial value is 5 minutes, and then the burn rate, like, could you go through and explain this formula, like, how it's doing it?
Well, all right. You start off, you're measuring how many calories this person has burned initially after 5 minutes. So right away, initially after 5 minutes, this first time you output something, you're going to put minutes is going to be 5 and calories is going to be 18, because you're looking at the person after the person has been on this treadmill for 5 minutes.
It's going to be 5 times 3.6.
Yes, that's what delta cal. Okay, it's 5 times 3.6. Yes. Then, now minutes is increasing. You're increasing minutes by 5. You're adding 5 to minutes every time you go through the loop, because that's your step value is 5. The step value here is 5. Your initial value is 5.
And then when it's
yes.
When it goes to print out, it's printing minutes and calories. Then
yes.
What's that extra line for? Like, what is the calories equal calories plus delta calories? Like,
because
I don't get that.
You're doing this every 5 minutes. So after the next 5 minutes, how many calories have you burned? Well, since you burn 18 calories every minute, you burn 18 calories every 5 minutes. After the next 5 minutes, you're going to add 18 to the current value of your calories. So initially, you burned 18 calories at 5 minutes. At 10 minutes, you've burned 36 calories.
So like on 5, so on that the second time runs through this set, right? It's going to put 5 equals, like, so calories is 5 or is 18, right? And then equals 18 plus, that would be 10 times 3.6.
It's 18 plus 36 is 54. So the third time through the loop, you burn 50, yes.
But when it's multiplying on the second, from the first time that it goes through to the second time it goes through. From the first time it goes through, calories equal 18, right?
Yes.
And then that equals calories, which is 18 plus this next time that it's going through, which would be 10
is 18
times
again. So it's 18 plus 18 is 36. That's after 10 minutes.
Okay, may I make another attempt at this?
Sure.
Okay, so delta cals is going to be established the unchanging value of step value times the burn rate. And then in that next line, we say that cals is then going to take this, is going to become, you know, whatever value that delta cals is. So the line that says cals equals cals plus delta cals, we are now reestablishing the value of cals as the dynamic value of whatever that cals plus delta cals is in relation to the for loop. Am I saying that correctly?
Yes, because you evaluate the right-hand side of the assignment statement. Initially, cals is 18. Then so the first time through the loop, you print out minutes is 5, cals is 18. In the next statement, you evaluate the right-hand side of the statement. The right-hand side of the statement is 18 plus 18 is 36. You then assign 36 back to cals. So cals changes from 18 to 36, yes.
18 by, getting 18 by multiplying rate times initial value?
Yes, but you get the 18 by multiplying 5 times 3.6.
And is that delta calories or the calories? So is it doing multiplication twice?
Look, here's the thing. See, your
So
calories.
It's doing 3.6 times 5 plus 3.6 times 5.
The second time through the loop, yes. The first time through the loop, yes. Yes. Initially, cals is 18. It starts out at 18 because you're starting at 5 minutes. See, you start saying how many calories the person has burned at the 5-minute mark. So you're already starting out at 5 minutes. Now, it's also the case that your calories are changing by 18 calories every 5 minutes. So you have to say, okay, my original value, I had 18 calories at the first 5 minutes. How many calories do I have after 10 minutes? Since 5 minutes has elapsed from 5 minutes to 10 minutes, I simply add to my 5-minute amount, or my 5-minute calories, the amount of calories I burn in 5 more minutes. So in 10 minutes, I burned 18 plus 18 calories. So after 10 minutes, I burned 36 calories. Now, in another 5 minutes, I'm going to burn another 18 calories. So it's 36 plus 18 or 54. Now, after another 10 minutes, I burned 54 calories. I'm sorry, another 5 minutes. I burned 54 calories after 15 minutes or so. So after another 5 minutes, I have to add another 18 to 54. 18 plus 54, I believe, is 72. At least I hope it is. Yeah, it's 72. So now I burned 72 calories. All right, how many calories have I burned after? I burned 72 calories now. How many more calories have I burned after another 18 minutes?
15 minutes, 18?
72 plus 18. If I burned 72 calories now, how many calories have I burned after 5 more minutes? If I'm burning 18 calories per 5 minutes.
90.
72 plus 18 is 90, yes. Okay, now after another 5 minutes has elapsed, I burned 90 calories now. Another 5 minutes have gone by. How many calories have I burned now?
108.
That's right.
So that last line that says cals equals cals plus delta cals, if we were to put all the numbers, like if we were to kind of like write out every step of the loop with the numbers plugged in, that second cals in that last line, that number would change each time, correct?
Yes.
Okay, got it.
When the loop ends, the actual value of cals is going to be 18 plus 108, or 126. But we don't print that simply because we only want to know how many calories have been burned when minutes is equal to the final value. I mean, I could rewrite this so it would add the calories first, and that would maybe that would make it a little better for everyone. So I can just start this at 0 now. So let me here. Let's just copy the whole. Let's copy the loop. Just copy the whole thing, and you'll see a slightly different way of doing it, which you might like better or make more sense. Okay, so this time I'll set cows equal to 0 right here. And then inside the body of the loop, I'll do this. Remove this, cut. And I'll paste this in here, paste. Okay, now we'll get the same result. Okay, we'll get the same result, but it might make it a little easier for you because now cal starts at 0. And then we start off, 5 minutes elapses, and now I calculate here, let's see what we get. Okay, see, we get the same answers. There and there. So perhaps that one makes a little bit more sense doing it that way. I can show 2 windows at the same time. Progress. Okay. All right, so you get the same result, but you notice the initialization is a little different. I start off cows equal to 0, and then in the body of my loop, 5 minutes elapses to, 5 minutes elapse, so I calculate my calories, and now I got 18 calories now. Rather than initializing the thing to 18 and adding the calories after I do the printing, I now add the calories first and then print. How are we doing?
Better.
Do we move on? Would you like to see this using a while loop?
Yes.
I'm still working on that real quick.
All right, let's do it with a while loop. Okay, let's see what we do. So we're just going to copy all this stuff here. We'll just initialize everything again. Copy. Paste. Now we start off with minutes equal to 5. I think that's how I have to do it. Let's see. While minutes are less than or equal to finval. Oh no, I can do it. I'm sorry. Let's do this. Did not put 5 there. Let's use this with init val. Minutes equal any val. And while minutes are less than or equal to finval, I love these great names, finval. Okay. Now, wait, let's see. All right, so now I calculate my value. Okay, let me think. I calculate my values. Cows equals cows plus delta cows. Delta cows. I do a print minutes comma cows. And now I got to add 5 to minutes. Minutes, see, before it was adding minutes for you. Minutes equal minutes plus any val. Okay, let's call it, let's create another variable so we don't get mixed up.
There's a colon that goes behind finval, yeah?
Yeah, right here, yes. Let's see, delta min equals 5. And so just call that delta min.
What does min mean?
Stands for minutes. You're changing it every 5 minutes.
The difference minutes?
I'm sorry, yes. Remember, you're taking the measure every 5 minutes. Here, maybe miss the way. I'll set minutes equal to, let me think. Actually, the way I have it set up, yes.
Why are you using step value in this one instead of initial value?
I'm sorry, say that again.
Are we using step value burn rate? Is that what we did on the other ones?
This is a while loop, so I have to do. I have to do more initialization. With a for loop, a lot of that is built into the for loop structure. With a while loop, you have to do a little more work. So if you compare these, though,
like on the other ones, I have something different. Like I think you changed it. You did not before. It wasn't delta calories equals step value times burn rate, was it?
Yes, it always was delta calories equals step value times burn rate. Always it was that.
I have delta calories as initial value times burn rate, not step value. Both the same number will give you the same answer, but we have step value and initial value, and they're both the same number, but like we have in the formula, and mine had initial value when I typed out the first time.
He changed it.
I guess I changed it to make more, so I was hoping to make more sense.
Yeah, you had changed it a while back from initial value to step value.
Okay. Yes, I do remember that now. I do remember that. All right, so here's our while loop. It's the same structure. Let's see, we have delta minutes equals 5. We didn't have that in the for loop because the for loop was changing things for us. So now we have to change minutes by ourselves. Here, I'll just call it delta min. It doesn't matter. Yeah, that can be step val as well. Fine. Okay.
I have another question.
One moment. Let me fix this before I forget, get mixed up. All right, let me put step val here. Okay, yes. What is your question?
Well, okay, you fixed it. So is it the case that for all for loops, it's always going to be a function of like the lower range, the higher range, and then the intervals, and then the while loops will always be a function, I shouldn't say function, but will always be dependent on a greater than or less than, like it goes until it reaches a certain number or certain value?
Yes, but you could make it go up or down.
Right, okay.
But yes, you're always going to have a stopping condition. And so in this case, we're saying while minutes is less than fin val, we are going to, and I should call that any val, sorry, minutes equals any val, just to be consistent. There we go, I val. So, okay, so you notice it's, okay, so here we have any val, fin val. Here we have any val, minutes gets any val, and minutes can be less than or equal to fin val. Let's see, so we have cows. Let's see, cows equal plus or less, print minutes. And now here in this case, now I have to increment minutes myself. In the for loop was changing minutes for me. So
can minutes be above print?
Say that again.
Can minutes equal minutes plus step value above print?
No, because what you want to do is you want to calculate the minute. Let's see. You want to calculate the calories for a particular value of minutes. So if I put the minutes first, that would be wrong. I could do it, certainly. I'd have to change the thing around a bit, but yes, it depends. See, you're determining how minutes and calories are connected. So if I start out here, minutes equals a nit val, at 5 minutes. Then I better have calories be the same calories for 5 minutes. So the way I did that is I said calories equal to 0, and then I added the delta. I added 3.6 or whatever it is, or 18 or something. Yeah, 18 to calories. So we'll have the same value, the appropriate value of minutes. See, minutes starts out at 5, and calories start at 0. But after 5 minutes, you were supposed to burn 18 calories. But here, let's do this. Let's do it this way. So I can always do it like this and make this. Oh my God.
When I run this last one, I get 2 values for 30.
I beg your pardon? You
When
get
I
2
run
values.
the last one, I get 30.
You get 2 values for what?
Like I get 30 for 30. I get 108 and 30 right below it, which is 18.
Well, I mean, do you get, see, what you're supposed to get is the same output for all 3 loops. Do you get the same output for all 3 loops? It doesn't matter what the final values of minutes are. It matters what your output is.
I do get the same value for all inputs.
I get
the same value
for all 3 loops. Inputs. Yes, but are you getting the same value for all 3 loops?
All of the values except for 30, because I get 30 twice in the last version of it. I get I get 10, 15, 20, 25, 30, 30.
Okay, then you don't have what I typed in because I'm getting the same value for all 3 loops. You can see my output. You have something else. Either you initialize it incorrectly or something else is going wrong. Let's look at this last one to see what's going on. So first, delta cows is again step val plus burn rate, or 5 times 3.6. Cows is 0. Minutes is a nit val, or minutes is 5. So you say, well, minutes is less than or equal to 30. You calculate your calories. Then you print out minutes and calories. You add 5 to minutes. Now you could do this. Here, let me do another example here. The same program, just a slightly different initialization. So now I'll set this one to 0, the minutes to 0. And then I'll add minutes. Right here, I'll put minutes equals minutes. Oh, God. All right, here we go. Minutes equal minutes plus step val. I'll take the minutes out of here. There. So I get the same result each time, but here now I'm initializing calories and minutes both to 0. I'll say, well, minutes are less than fin val. No, that's got to be less than now, rather than less than or equal to. That may have been, yes.
I did the equation that you just printed, or that you just presented, and
Yeah.
And it went over 30. It went 1 over 30.
That's because you have less than or equal to. Just have less than.
Solve.
So okay, now it works.
Yes. Okay, let's save this one now. But it depends on how you assign the initial values, how it works. The for loops do the initial value in a very consistent way. With while loops, you have a lot of freedom how you initialize your loop. Yes?
What it was, I think, equal. That equal sign is what messed it up?
Yes, you had less than or equal to. You should have had less than.
What did you say? The for loops do what in a consistent way?
They increment, they change the loop control variables. They do the initialization in a consistent way. In the 2 while loops I wrote, you notice I initialized the variables in 2 different ways. I did minutes equal, the first time minutes equals a init value, and the second time you have minutes equals 0. Because of that, I have to increment the minutes in different places. The first time I incremented the minutes after I printed the minutes. The second time I incremented the minutes before I printed the minutes. I also had to change the loop condition. Instead of having minutes less than or equal to fin val, which is the way it is in the first while loop, I have to have minutes less than fin val. With for loops, it's always the same thing. For minutes in this range from init val to fin val, and so on. So it's less confusing. If you can use a for loop, you should use a for loop instead of a while loop. While loops, it's much easier to make a mistake. For loops have a tighter structure and it's harder to mess it up. Because you have to specify what's the initial value, what's the final value, how am I changing, how am I getting from the initial value to the final value. All that proceeds in a particular order.
Are there instances where you would be required to use a while loop instead of a for loop, or could you always try to use a for loop?
You can always try to use a for loop.
So why would you use while loops?
You use a while, see, you use a for loop when you know exactly how many times you're going to execute the body of the loop. We know
I see.
You use a while loop. That's why a while loop is inappropriate for this problem, because we know how many times you're going to do the loop from init val to fin val. That's it. There's no there. It's always going to do. It's always going to execute the same number of times. If you don't know how many times the loop is going to execute, then you use a while loop.
So with the while loop, you can essentially say, keep doing this until you can't do it anymore.
Yes.
Okay.
Though the can't do anymore requires a little bit of thought. See, figuring out your loop condition is a little bit more difficult with a while loop than with a for loop. This is a very simple program, so the while loop and the for loop are kind of equivalent. They do about the same things, so it's easy to switch back and forth between a while loop and a for loop. We're going to move on to some programs in a little bit. By the way, if we don't get all these done tonight, we're going to go back, and you don't have to do the classwork either if we haven't gotten to that point. We can just push it back to next week. It's not a problem. The important thing, I don't have to go at a particular speed. So I just want to make sure everybody understands this, and we can move on to the stuff the next week. I'll change the for loop. I'll change the homework and the classwork to reflect what we've done tonight. Okay. All right. All right. All right. So everyone's kind of happy with this one. Okay. So I'm going to save this, and this is going to be program 2. All right, so this is my best.
Program 3.
No, we only did one program, as far as I know. What was what? We did program 1. What was program 2? We just did that one. Okay, let's save this. File, save as. Oh, God, all right, let's get out of here. There it is. And one moment. Okay. Oh, that's where we are. No, that's not where we are. Okay, so this is program 2. Okay, onward, ever onward. All right, that knocks that guy out of the park. Now, what's the third one? Okay, program 3, write a program that asks the user for a positive integer no greater than 15. The program should then display a square on the screen using the character X. The number, there we go. The number entered by the user. Okay, this is a for loop, and we're kind of, this is I'm going to skip this one. Let me see. I want to get to while loops. It's almost 9 o'clock now. So I want to do
Is there a way how like you did office hours, like where you gave us it and then like asked us like to fill in rest and or maybe like to think, because my problem is like I want to be able to do it where there's no one explaining how to do it, but I don't think I can do that.
I'm not sure. What are you asking me?
Well, like if you told me to do something similar to what you just told me, we just went over, I would have no clue. I wouldn't be able to do it. Like so, like you like maybe like give us like like what as we go, like we might think the answer would be.
I didn't hear the last sentence.
So like as we go, do you maybe like say what do you think next line might be or something like that?
I mean, ask questions
and like
wait for you to answer.
Yeah.
Sure. Okay. Okay. All right. Let's see. We're going to do a while loop. I'll get back to this program 3 later. Let's do program 4. Read a number from the keyboard. Repeat the following steps. If the number is even, then divide the number by 2, else multiply the number by 3, add 1 to the product, blah, 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 until the number equals 1. Okay, so we're going to start writing this thing. All right, so the numbers keeps changing. It gets larger, smaller, and so on. In terms of a while loop, what should your stopping condition be? So you're saying, while this is not true, do something.
Until the number equals 1.
That's a stopping condition, but that's not a while condition. The while condition, think of it this way. The while condition is a negation of the stopping condition. Because you're saying, go on, yes.
Oh, I'm sorry. I didn't mean to cut you off.
No, fine, that's fine, please.
So if the end condition is that the number equals 1, then we are asking the program to keep running while the number is greater than 1.
You got it.
Okay.
Yes, that's your stopping condition. So that's how we could create our loop. Okay, let me just copy all this stuff. We're going to make this a comment. We're going to try to go. Yes, go on.
Would like first line of our program be while n while n is greater than 1?
Yes. Yes, okay. That's the stopping. See, the while condition is the negation or the opposite of the stopping condition. Because a while condition is, while this condition is not true, keep going. Well, what does it mean for a positive integer not to be equal to 1? It means it's greater than 1. If there's any questions on that one. How did I come up with the while condition? Go through here, copy. Here's this stuff. Here's Python. Let's close this up.
So are we going to do work on that thing we talked about?
We're going to do program 4 now.
Okay.
This is program 4. We might skip a couple of them. I want ones that it's fairly easy to understand. So let's go back to Python. And when is this? Let me get a new file. Okay, I already saved that one, so I don't need it. Okay, so these are all going to be comments. Comment. 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 I don't know if there's a multi-line comment command in Python. I'll have to find that out. So pardon me.
Let's see.
3 single quotes.
3 single quotes. Thank you. So, all right. Well, I've already done this, so I might as well. 3 single quotes. Thank you. I'll get to that. All right, so here we go. Okay, so here we go. Here we go. Start off right here. Well, we'll just okay. I won't do that. All right, so good. Let's see. So I want okay. I want to read a number from the keyboard. All right, here we go. Let's see. Number. Okay, I'm in a hurry, so I won't try to get fancy. Equals input. Please enter a positive integer. Like that. Okay. All right. Okay. All right, let's just do some error. Let's just assume it's correct. So your while condition is going to be, as you pointed out, while number is greater than 1, colon. Okie dokie.
Quick question.
Yes.
Should we not be converting the input into an integer first?
That's what intelligent people would do, yes. Sorry, I forget to do that. I'm so sorry. Number equals int number.
Could we put number equals int input to a number?
I'm sorry, say that again?
Yes.
Put int or input?
You mean put int around input? Yes, you can do that. If you want, that's fine. If you want to keep track, yeah, you can do that. That's fine. I just do it this way so I have all the steps in front of me. But sure. Okay, now what you have to do is try to find out if this is an odd number or an even number. Okay, what function did we just learn about today that would allow us to find out if a number is odd or even?
The percentage sign.
Correct. So what would we, how would we know, what would we do? Okay, so if what?
If it doesn't have, so if the percentage equals 0, I don't know what the name of that percentage thing is.
It's called the modulus operator.
Okay.
If modulus 2 equals 0, colon. Okay, what are we supposed to do then? Look up at our program up here. If number is even, what do?
Divided by 2.
That's right. Now this is another one. Number equals number divided by 2. But because of the weird way that Python works, it's going to try to convert the thing to a float, which we don't want. Now, you're saying, well, what happens if it has some kind of decimal fraction value? Well, no, that's not going to happen, because if it's an even number, 2 is going to divide it without remainder. So we can get those. So we're fine here.
Does the first parentheses of this last line need to be right up against the T of integer? There's a space in between int and your parentheses.
No, it's just a function. No, it's free form in that sense. It skips white space.
Okay. That's
called white space. So it doesn't matter. The only thing you can't do is put it on a separate line. I don't think that'll work. Let me see though. Let's see what kind of error I'll get. Yeah. See, it doesn't like that. Oh, I'm so sorry. That's supposed to be double equal. That was just the yes. Yeah, you have to have 2 equal signs to compare 2 numbers. Let me close this window here. Okay, let's try it again. I'm just trying to generate some error because there's something I don't know. So I want to see what happens. Okay. 27. All right, well, what do you know about that? I didn't know it would do that. Well,
so you didn't get an error?
No, I expected to, but I didn't. Still, I like to keep things close. All righty. Now, what's the next thing we do?
Else.
And
number equals. Sorry.
Yeah, no. Please go on. else.
Number equals integer number times 3.
Okay.
Is that what the
Slight
sentence is?
correction, not really that important, but it's only division where Python tries to convert something to float. If you multiply, it's going to say, if I multiply two integers, see, if you multiply two integers together, you're going to get an integer. If you divide two integers, you might get a floating
I
point
see.
number.
Right.
Okay, so you don't have to do the int this time.
Okay.
The number equals number, or again, this is my convention, was number. Now, you can make a more complicated expression than this. What else should I do here?
Should we put 3 times number in parentheses and then plus 1?
That would be a huge mistake if you did that.
Oh,
No,
never mind.
you have to do the product. You have to do the product. See, what you're suggesting is doing this. I assume this is what you're suggesting. And this is not what the problem is asking for.
No. I mean put parentheses around the entire thing, but also I'm doing too much like actual math versus doing the formulas of Python. Like, so if we had put, like as you're doing right now, 3 times number plus 1, would that not work?
I mean, put the whole thing in parentheses?
No. Put the plus 1 outside of the parentheses.
Oh, okay, go. Thank you. That gives me an opportunity to opine on another topic. Okay. Yes, this will work, but it's not necessary because of something called operator precedence. You see, multiplication has a higher precedence than addition. So what's going to happen is Python will multiply 3 times 3 and number together and then do the addition. So you don't need the parentheses. Now, if you want to do the other way around, if you wanted to add 1 to number and then multiply, then you could put the parentheses in like that. And that'll do
I have a question.
Yes.
Why did n, what's that thing, the percentage thing called again?
The modulus operator?
Yeah, so what is why are we using if number is if the modulus is 2?
Zero.
I don't
That's
understand.
because we're trying to figure out if the number is even. Now, how do you know if an integer is an even number? Well,
It
if you
divides
divide,
evenly, and
say that again.
if it divides evenly over 2.
If 2 divides it without remainder. But yes, the way that you said it is good too. Well, you see, if number modulo 2 equals 0, it means that when you divide the number by 2, you don't get a remainder. And therefore, it's an even number. Now, back to this line here. If everyone's happy with that one. Okay. If number, okay, anyway, you put the parentheses in there to control the order in which the operators are executed. So you want to do addition first, then multiplication. Excuse me. You want to do addition first. Oh my God. Pardon me. If you want to do addition first, then multiplication, then you put the parentheses around number plus 1. But because multiplication has a higher precedence than addition, you don't need the parentheses because Python will multiply. Well, excuse me. Python will multiply first, then add. So you don't need them. Okay, let's just print these guys out and see what we get. Here, let me do backspace. Okay, let me go up 1 line. Tab over. Okay, now we'll just do print number.
Do we do print on the same indentation space as else?
What I have there is correct. What are you asking? Get one more time.
So print goes on the same line of indentation as else and if.
Yes, because you don't want to only print something. See, if I line the print underneath number equals 3 times number plus 1, it would only print when the number was odd. See, if I did this, let's just do this. I did this, and the only time number would print, only time you would print something is when number was odd. Because that else is controlling the two statements. Let's run the thing and see what we get, and we'll see if what I'm saying is true or not, assuming it doesn't have any errors. Actually, you might get an infinite loop, but that's fine.
I got a really long one.
Please enter a number. Okay, so I'll do 77. You'll notice it only prints the, it printed the odd numbers. What is going on here? That's because
97.
No, it's multiplying. A moment here. What do I got wrong here? I said 77. If it's odd, I did 70. Oh, I see what happens. Yeah, I'm only printing the odd. Yeah, wait 1 second. That is weird. Oh, that's
the numbers be bigger?
If it's odd, no, it'll get no. See, you're not printing this part here when it divides by 2. You're only printing when it multiplies by 3. So
right.
So we're indenting even further.
I'm sorry. Yeah, I guess you're.
So the print is even further.
Well, could you if you run this again?
One moment. Say that again. Yes. What is your question? You want me to run it again?
I don't know if you're talking to Randy or me.
I'll talk to you.
Okay. So may I see the results of when you run this again? Because I would have thought if you put in 77, then those numbers would have been bigger, right?
No,
Because
well, yes. Well, no, not quite. See, if it's equal to 77,
then it should be multiplied by 3.
Odd number. And let's see, what's 3 times 77? Well, I don't know. It's okay. 3 times 77 is something. As soon as you get
231.
231. Now it's 232 because you add 1 to it.
Right.
Now, as soon as you get the 232, you can divide it by 2. Now, 232 is also an even number. You're going to keep dividing it by 2. But I'm not sure why we're getting. What I don't understand.
230 divided by 2 is 88.
Wait. So
Yes.
why is the calculation not ending after you multiply by 3 and add 1 to the product with your odd number? Why would it then go back and then divide the number? Or is that that is the loop? Is that as soon as you get an even number, it'll go back up and divide by 2?
Yes. As soon as it gets to 16, see, 16 is a power of 2. So every time you get 16, it's going to keep dividing. But I'm something worried. I don't understand why I'm getting the thing to print when I thought that I'd align this thing with the odd numbers here. Let me unindent this a little bit and see what I get now.
It's longer.
77 again.
And also, why is it 88? Oh, okay, there we go. I was wondering where the 116 went.
Yeah, no,
because 230 divided by 2 is 88.
Excuse me? No, 232 divided by 2 is 88? No.
Well, you're going to keep dividing it by 2. 232 divided by 2 is 116.
Right. I'm saying in your first, when you run it the first time, the first result, it goes from 232 to 88.
230, yes, because we're skipping, because it's not displaying any of the odd numbers there. I don't know. Frankly, I don't know why. I don't understand this output. As I try to explain it to you,
right?
I'm unable to explain it to myself. Because I would have thought that okay, now I know why we're just getting even numbers. Because when you multiply an odd number by 3 and add 1 to it, you get an even number. So I see the even. Okay, I got it now. So when numbers odd, yeah, that's why. See, when numbers odd, you're going to multiply by 3 and add 1 to it. You're going to get you're going to get an even number. So you're always going to print even numbers here. You're just not going to print any odd numbers. Because see, when you divide number by 2, you may or may not get an odd number. Let's put this back a bit so we can see what's going on. So first, let's convince ourselves what we're saying is correct. Oh, one moment. So I'll do this again. And I'll type in 77. Let me close this window. Let me close this window so we can get started here. All right, so we'll do it again. Run, module. Okay, so I'll type 77. Now, the reason you're only getting even numbers here is because the first thing you do is you multiply 3 times 77 plus 1 is 232. All right, when you divide 232 by 2, you get 116, right? Then you get 58. Then 58 divided by 2 is 29. That's an odd number. So you come back here. What's 3 times 50?
Wait.
29. Yeah, I'm sorry.
Sorry.
Which
Where did the 58 come from?
106.
I typed 77. All right,
Correct.
77 times 3 is 231 plus 1 is 232. Now, when I divide 232 by 2, I get 116. When I divide 116 by 2, and we're not going to print that because the way these are aligned, we're not printing the even numbers. We're not going to print this stuff up here.
Wait, but is 116 not an even number?
Yes, but you're not printing the even. You're not okay.
Oh, okay.
Eventually,
I
you're
got
going
it.
to get an odd. Well, everyone else. Okay, let's get everyone else on board. Eventually, you're going to get an odd number. Okay. When you get an odd number, that odd number is immediately converted to an even number.
Right.
3 times the odd number plus 1 gives you an even number. So you're never going to print an odd number. Because as soon as the number is odd, you convert it to even. The only time you should print an odd number or get an odd number is if you print something up here.
I'm just wondering why it skipped from 232 to 88. Because
I'll go through. It didn't skip. It just didn't print. You start off 77.
Is it only to print the number integer number divided by 2 and the number equal 3 times number plus 1? Is it only printing stuff on the same level as it?
First of all, you're never going to get to print an odd number. No odd number will ever be printed.
after your initial step, correct?
It's never going to be, well, after, I never print the initial number.
Right. No, I'm just saying you were never going to get an odd number
Printed.
Because even if you put in an odd number at the very beginning, it'll automatically change it into an even integer.
Yes.
Right. But
well, it's only, I thought it was, so it's only printing whenever number is evenly divided by 2, right? Because like if it's a 0, it
well, not all the time. Yes, it's only going to print even numbers. Yeah, that's quite true.
Yeah. So only it's because print is under the condition about even numbers.
No, it's under the condition for odd numbers. But as soon as you get an odd number, you convert this. As soon as the number is odd, this statement here converts it to an even number.
So
isn't print still under the same condition of while n is greater than 1? So everything above that applies to it?
Every number is greater than 1, yes, you're going to. Yes, well, while the number is greater than 1, you're going to perform these calculations
and print the number.
And print the number if it's initially odd.
So we've established.
When the number is odd, you get to this part of your program, the else part. Oh, okay. Pardon me.
Bless you?
No, I dropped something.
Oh, okay. Never mind.
Anyway.
I don't know. It sounded like he was sneezing.
No.
I sounded like you were attacked.
No, that was the dish of food falling on the floor. Okay, anyway. Let me move this out of the way. Okay, where were we?
Okay, so if we've established that after an initial input, say we put an odd number, we will never get an odd number again based on the formula that we've put in.
You will get an odd, okay, I apologize for interrupting you. You will get an odd number, you just won't print an odd number. The way it's set up, you just see, if the number is odd, that's when when you get to the else part. You then multiply the number by 3 and add 1 to it. That gives you an even number.
So, but I'm saying if you initially put in an odd number,
yes,
and this formula says as soon as you get an odd number, you're going to multiply it by 3 and add a 1, you will forever have an even number, will you not? There's no way that in multiplying by 3 and adding by 1, you would ever get an odd number again. Is that not true?
But yes, but you're ignoring the first calculation. If the number is even, you divide it by 2. So eventually, unless an even number is a power of 2, you will have like 16 or 32 or 64. You can keep getting those, you can keep dividing a power of 2 by 2 until it's equal to 1. But a number like 58, 58 is 2 times 59. I mean 58 times 29. So as soon as you divide 58 by 2, you get an odd number.
I'm just not doing math right. Okay. No, you're yes, correct.
Watch. Let's move the print statement out so we can see what's happening, because we've been hiding it. I couldn't figure out why we weren't getting even. Okay, let's do 77 again. Now watch. Now it's 232, 116.
Okay, so now it's showing 116.
Right. 58, 29.
But it wasn't showing 116 before when you had the print initially under the number.
Yes, because that's an even number.
Oh my God. Okay.
Look, no, here, let's one more time. Here.
What am I missing?
Print
32. Okay, first happens it's 77. So that's an odd number, so you get to here. If you multiply 77 by 3, add 1 to it, and you have 232. So you come back again because you're looping. You say, is 232 even? Yes. So you divide it by 2, you get 116. 116 even? Yes. You divide that by 2, you get 58. Is 58 even? Yes.
So are you?
Go on.
Are you printing? You printing after one of these?
I'm printing all the numbers over here on the side. Can you see this window over here?
So are you printing? So every time it runs through that cycle, are you printing it?
Yes, I'm printing all the numbers now.
Okay, and like when does that print? Like when does it change? You have it indented under the numbers versus when you have it indented under if.
It only prints if the number is initially odd. If it's part of the else part, when you indent it like this, it is part of the else.
Which case though?
I'm sorry?
In which case does it do which case?
It prints when number is odd.
It's under which thing though? Like which,
it's under
you know
the
what I'm
else
saying?
part.
I'm asking like
it is under the else part. That means that it prints, something prints when number modulo 2 is not 0, when number modulo 2 is 1.
So printing the if, the else, rather than if it's under the else and indented under that, it's just print under the else.
Let's flip the switch.
I don't understand where this 88 is coming from.
Okay. All right, let's not flip the switch. All right, it starts at 77. All right, 77 times 3 plus 1 is 232. If it's 77, that means number modulo 2 is 1. That means you come to the else part. So 3 times 77 plus 1 is 232. You print 232. But that's even. So you divide here. Let me put it back the way it should be. So what you do is divide.
No. But we got the 88 because that print was under the number, not under the else. I'm just trying to figure out what the difference is and why it's printing differently depending on where that print is indented.
Yeah.
Or
All
indented
right.
rather.
Then let's start off again. You can multiply 77 times 3 and add 1 if you get 232. That's an even number. That means that you don't print it, you simply divide it by 2. So 232 divided by 2 is 116. That's still an even number, so you don't print it. You divide it by 2 again, you get 88. That's still an even number. I'm 116, excuse me. You divide 116 by 2, that's still an even number, you get 58. Still
So where did this 88 come from?
The 88's coming up, don't worry, it'll be there soon. So now it's 58. Divide that by 2, you get 29. All right, now that's an odd number. So you get to this part of the program. Now, 3 times 29 is 87, plus 1 is 88.
Okay.
Then,
I got it.
Okay, good.
Holy crap.
Oh, that was fun.
Ooh.
Now we put the number back where it was. Okay, now since you had so much fun with that, let's flip the switch a bit, and we're going to do it a little differently. Copy, I'll move this down here. This is going to be the same program, slightly changed. So this time I'll put if number modulo 1 or 2 is equal to 1, then I just move this up here. And I put, this is going to be 3 times number plus 1. And I'll just undid that as we did before, and this will be number equals number divided by 2. Hold on.
The formula that's under if number, should that not have an equal sign somewhere? Should that not be assigned a value somewhere?
One moment. I'm mixed up enough as it is. Just give me a second, and I'll answer your question. Let me finish this part. Okay, now what is your question?
The 3 times number plus 1, should that not be assigned a value?
Yeah, it would be, yes. Yes, thank you. Yes. Right. Thank you.
Okay.
Okay, now these are the same thing. But if I do the second one, we're going to slightly different, we're going to different output. Okay, the gentleman said it was 2, or someone told me it was 2 apostrophes. There we go. Thank you so much, whoever told me that.
It's William.
Yes.
Them.
Okay. Okay, now we're going to get a little bit different output now. Now we're just going to really get just even numbers. Run module. Okay, I'll type 77 again. Here, let me stop this. Let's get another output page. And I'll also, what else? I want to put a colon here. I'm going to put a space between my input thing, my prompt. I'll do that up here as well. And there we go. Okay, slightly different output, as you will see in just a moment. Okay, 77. Now, is that a little bit different from what you saw before? See, that's what we get now. Because we're only printing if the number is originally even. And then we could get an odd number because, see, we divide 58 by 20, we divide 58 by 2, we get 29. So that one's going to be odd. You come back up here, we multiply that 58 by something, I'm sorry, that 29 by something, and we get 88. Well, 88 is even now. And so, I'm sorry, that's still even, yeah, 88. Well, whatever, we're getting different printing, great. But if I stop the indenting, I'll get completely different output. Let me just make this so it's correct, and we can discuss the differences. And we can just take this out. So I'm going to send this to you in a little bit. Oh, come on, guys. Come on. All right, there we go. Okay, good. All right. Now, by switching the if condition, see here it says if number modulo 2 equals 0, and here it says if number modulo 2 equals 1. Now I get exactly the same output, except for one time. The first time I'm testing for an even number, and the second time I'm testing for an odd number. But it still works, because if a number's not even, it's got to be odd. If the number's not odd, it's got to be even. So here we go. If the number is not odd, it's got to be even. If the number is not even, it's got to be odd. So we get the same output for both of them. Okay. How are we doing?
But so does print the same output?
Yes, it'll print the same
Oh,
output.
okay. Yeah.
Not now, yes. The reason you're going to get the same output. Yes. Good grief.
So again, that says that it's going to print the first condition or the second condition are met.
One moment.
Oh, are you okay?
No, I've got
Are you choking?
swallow some water.
Oh.
Okay. The way it's written now, you're going to get the same output for both programs because you're printing unconditionally. If I move
Printing while
unconditionally, meaning you're always going to print something for every value of number.
either condition is upheld.
I'm sorry, what I mean is that the print statement is not controlled by an if or by an else. If I move the print statement underneath number, then I'm not going to get the same output.
When you're printing, it's underneath number, only printing else.
Yes, if you align it with
right?
number equals 3 times number plus 1, then it's only going to print when the else part is when it's printing the else part.
Here, you're printing when it's under while, basically.
Right
So
now, I'm
while
printing when
the
it's not.
condition
Right now, it's printing unconditionally, whether it's under the.
So-
it's not part of the. It's not part of the if statement. The print statement is
so
not.
it's while all of it, right?
The print statement is not part of the if statement.
But it's underneath while, and it's indented.
It's part of the while, yes, but it's not indented under number. You see, now it's under number. That means that it's part of the else.
Now,
Yes.
so my question is, when it's under else, it's under the constraint of while. While any conditions are met, it's going to print.
Yes, but there's another constraint when you align it with the else. It's only going to print while the condition is true, and it's going to print while number is greater than 1, and there's a further constraint, namely that the number is odd.
So if it's odd, it won't print.
No, no. Do you see the second while loop right here that I've highlighted? Right here? Do you see that? You'll notice that the print command is under the else. It's indented under the else. Do you see that?
So only going to print that condition is. I see that.
It's only going to print.
What my question is.
Yes.
My question is like the regular one, the one above it. That is going to print if either condition is met. If it's odd or if it's even.
Yes.
If it is.
It's if it's odd or even. It's not part of the if statement. It's not part.
I understand that it's not part of the if statement. I see if of it.
But it's not part of the if statement. It's not controlled by the if condition.
It's controlled by the while.
Yes. Well, the while. Yes, that's quite true. Yes.
Okay. So like I'm just trying to see. I mean, like when you indent. So because if you took an indentation away from and if it was on the same level while, nothing would print.
Yes.
Okay.
Well, no, the original number, the number would print. It would not print during the loop. If you did this, it would only print after the loop ended. In fact, nothing would print then, except for the final number, which would be 1. Let's do that. So right now, the only thing we'll print will be 1. We'll get 2 1s. I hope. Let's try 77 again. And see, I just got 1. There's a 1 there. Now I'll do 77 again. And there's the second 1. That's because the print statements are not part of the while loop. So I have to indent them again to make them part of the while loop. So now they're part of the while loop. Oops, see, now they're not part of the while loop. Let me get this in here.
Kind of like things, it's like outlining, right? Like
it's like
anything
outlining.
indented.
Yes, it's like outlining, yes. Okay.
Okay,
let's knock this one. Let's get rid of this one. I think this is program. This is not program 2. I don't
It's
know.
4.
4. Okay, thank you. Where is it now? Da, 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 da. Da, da, da. I think this is it. Yeah, this is program 4. File, save as, and this is program 4. Thank you so much. Okay, so while loops, as you're seeing, are a lot more fun than for loops. Well, and the other thing is you're getting used to these weird if statements that, I mean, the way they handle compound statements. All right, let's see, what's the next one here? Okay. Oh my God. Actually, I made a mistake. I did number 3, 4 rather twice. Oh, we'll just leave it there. We're not going to do it. So it's 9:27. We just have time for more. One more. Okay, we're going to try to do program 7 and 8, which was going to be your classwork is going to be extension of this. So let's try to get this far. See what we can do. This is a guessing game. I'm thinking of a number between 1 and 100. And I'll tell you, and you have to guess the number. I'll tell you if the number is too high or too low, and you try to figure out what's going on. All right, let's see what we got here. So let's grab this guy. This is program 7. And I think this is all we're going to have time for tonight. And we'll come back and get it again next week. Not a problem. Okay. All right, let's get this thing in here. Okay, this it? No, that's not it. I think, let's close this up. Oh, there we go. All right, let me just cut a new file. File, new file. All righty, so we paste this guy in here. Oh, that's the unfortunate thing, is that sometimes when you do a paste, it gets rid of the end of line characters. And I don't think, oh my God. Okay, here we go. So I'll do down here, and if I recall, it's 3 single quotes. Okay, here we go. Write a program that's generate a random number and ask the user to guess what the number is. If the user's guess is too high, if the user's guess is higher than the random number, the program should display too high, try again. If the guess is too low, is lower than the random number, the program should display too low, try again. The program should use a loop that repeats until the user correctly, until the user correctly guesses the answer. All right, there we go. Okay. Okay, so we have to do the random number thing. I think we do from random imports randint. Oh, you have to close it, sorry. Okay, imports randint from random import seed. We don't really haven't done anything that could make us use a seed yet, but I figure what the heck. It just allows you to control the sequence of random numbers your program generates. We'll just say seed 7, or it doesn't matter. You just want to get the same result every time we run the program. Otherwise, it's going to use the system clock, which you don't want. All right, so anyway, so we're going to generate random numbers between 1 and 100. So I'll do min equals 1, max equals 100, and away we go. And so now we just do secret equals rand int. I'm not sure if it's min comma max or max comma min. Let's see, it's max comma min. All right, there we go. So we got that. Okay, now it's going to say, oh, all right. So now we got to read a number. We have a okay. We have a okay. Now we're going. Okay, so here we go. So we're supposed to print.
Guess a random number.
Guess equals input quote. Please enter a number between. Okay, I'm not gonna. Whatever. Between 1 and 1. I'm sorry. Yeah, please guess. Please guess. Random number between 1 and 100, space, quote, colon, quote, like that. All right, now. And for those of you who wanted me to do this, I will do this because why shouldn't I? There. So if you like that better, here we go. All right, so now our while loop. So this is going to be a while loop. And so what is our stopping condition?
Until they guess the number.
So what should be our loop condition?
While the number is not the guess.
Correct. While guess, oopsie, while guess is not equal to secret. Correct, correct, correct. Okay. All right, now we're supposed to evaluate the guess. All right. If guess, excuse me, I keep doing that. If guess is greater than secret, what should I do? Print something. What should I
Print
say?
too high.
Okay.
Print too high.
Too high. Not nothing. I was going to say not until class ends. Not, that wasn't too funny. Okay, too high.
Should there be a colon after the while line?
Yes. Yes, thank you. I will always forget that, and you will be kind enough to remember. Okay. All right. Now, here's where things get tricky. Do you want to do, okay, let's do the simplest way to do this is with one-way if statement. So we'll do the next one-way if statement is if guess.
No parentheses.
Guess.
Less than.
Less than secret. Print, quote, too low. Okay, now that's actually all we have to do. Well, I'm going to do it this way just for right now. And, oh, I guess we do, okay, I'm sorry.
Should we not have, oh, sorry.
Yeah, we're going to do guess equal to secret. All right.
Right. Should we not have some form of confirmation that the person has guessed the random number, something that prints success or I don't know.
Yeah, but see, here's the problem. Yeah, we are going to have it print success. The problem is, well, let me show you. Let's do the problem, and we can try to fix it in the next 25 minutes. If guess equals secret, hope I keep doing that. Print quote. Excuse me. Do it again. Print
Winner.
quote,
Winner.
parentheses again. Print quote. You win. Yay! All right. Let's play this and see what we get.
Colon after secret, next to last line.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Yeah, that's always going to happen. All right. There's a subtle error, and it's not. It's more of a logic error. I'm sorry. Okay.
Mine like keeps going and going and going.
Yes. Well, there's a reason for that, I think. Okay. Well, there is a reason, because this program will not end unless you guess the secret on the first try. Why is this program not going to end?
Because you haven't determined the parameters of when it ends.
Like mathematical secret.
if you didn't guess the secret on the first try, then it just goes on forever.
So what should we put in here?
Should we take the indentation down?
Oh my goodness. I gotta get some water.
Should if s equals secret, should that be like on the same line as while?
It has nothing to do with the if statements. Nothing to do with the if statements. There's a fundamental problem with your loop. Remember what I told you? There has to be something in the body of the loop that will change the loop condition. Look at the loop condition. Look at the body of your loop. Is there something in the body of the loop that will change the loop condition?
Yes, I agree with Joseph. Else. Joseph wrote in the chat that we need an else in there.
Not really.
Oh, okay, never mind.
Well, no, I mean, he is fundamentally correct. But he's correct, but we didn't choose to write the program that way. I said there was a problem with using these one-way if statements. But
I just feel like the random integer is so open-ended. How do we make it not so open-ended?
It's 1 to 100.
Oh, true.
Let me tell you something. If I made it 1 to 5, the loop still wouldn't end.
Are we not supposed to define random integer either?
It's defined right here.
That's secret, not random integer.
That is a random integer. That's the number we're trying to. Rand int is a function that we got when we did the import up here from random import rand int. Rand int is fine. There's no problem with rand int. There's a problem with the body of your loop. What your loop?
Can we put limits on how many times it loops?
We could do that, but we're not going to.
All right.
That's coming up. That's actually your homework assignment.
Awesome.
Or your classwork assignment. I can't remember which it was. But at any rate, I think it's your classwork.
Yes.
The problem is there's something missing from the body of the loop. Remember what I said. Is there anything in the body of the loop that will change your loop condition?
What? No. What is the body of the loop?
What's your loop condition?
What's the body of the loop?
The body of the loop is all the stuff here. This is the body of the loop.
So
control variables?
No. Well, first of all, remember I said what are your loop control variables? Guess and secret.
Right. Okay. As long as guess does not equal secret, then it's going to keep looping.
Yes. Is there anything in the body of your loop that will change guess or secret? Now, you can't change secret. So what do you have to change?
Guess.
Or is there anything in the body of your loop that will change guess? There's nothing in the body of the loop that will change guess. You got to make a copy of this thing. Copy.
Huh.
And then
paste.
put it after bottom.
I'm sorry. Well, you can't got you.
One
Well,
more question.
I have to indent it properly. That's one thing I have to do. Okay, now it's indented properly. So it's part of the while, but it's not part of the if. Now, if you run the thing, having played this for many years, I know how to do it. Why am I getting this?
You have to save the program first in order for it to run.
Oh, okay. So I'm going to call this thing
It was 7, right?
program 7. Yeah, program 7. Good. All right, here we go. Now, okay, so the first thing you do is you try 64 or 50. Well, 64 is easier. Too high. So you try 32. Too low. 64 minus 32 is 32. Half of that is 16. That's 48. Too high. 48 and 32, the difference is 16. Add 8 to 32, give you 40. Too low. It's between 40 and 48. 44. Too high. Between 44 and 40. 42. Okay. So the secret number is 42. Your program doesn't output that, but so there's a few things missing from your program. All right.
So it didn't print the you
Oh,
win.
No, that's just a that's you're just missing some output. There's no if statement. Oh, wait. If guess equals secret, no, the problem is this. It's never going to print that I win.
Unless you had guessed it on the first try?
Yes. Well, no, even
Okay.
if I guess it on the first try, it still won't print that I win.
It won't print that you win because you didn't put print in after guess, right?
Yes. It's because this is a test first loop. If I did it on the first guess, the while condition would be false. And the while condition would be false, and therefore I'd never go into the while loop. If I do it on a subsequent guess, let's see, I do it here, it'll get to the while condition, and it'll say the while condition will be false, and I'll never get into the body of the loop. Let's see. Let me look. I don't know how to do this. We've got 17 minutes. So let's see. Yes, go on. Sorry.
Just ask a quick question as to why copying and pasting the guess equals integer input, please guess the random number, why that prompt stopped the function from repeating to infinity?
Oh, because I was changing the while condition. See, I'm changing guess, which means I can eventually change the while condition.
I see. Okay.
Before, for the other anyone else, but just for anyone else, I mean, just the reason is the original, without that guess thing in the loop, there was nothing to change the while condition. The loop control variables are guess and secret. Secret doesn't change. So the only way you can change the loop condition is to change guess. And so by putting that in there, we did well. Okay.
I think that it work.
I'm sorry, go on.
I got it to work. I got it to work.
That's good. Well, it's not working correctly yet because it's not printing it in.
Make it work.
I'm sorry?
I got it to work for me. I changed it around. I put guess. I put guess equals secret, print you win after guess equals integer input guess again. I put it in chat.
That's fine. Yeah, fine. That's fine. That works okay. It would have been much better if you'd used a multi-branch if statement, but that's fine. Let's just work with this for right now, and we'll try to fix this and make it a little better. Moving where guess goes is actually a good move. Actually, that's a very good move. So what he did was this. Not something I would have thought of, but that's life. Let's see, let's try to get this to indent correctly. There we go. All right, I'll just put a blank line through there. And so this is what he did. So you check to see if the guess is too high or too low. And then you get another guess. And then you check to see if it's secret, you print and you win. Now, you don't really have to do that. What you could do is this. One moment. Oh my God. Excuse me. All right, let me take this out. That works well. But it would work just as well if you did this. You see, the only way you're going to get out of the loop is to guess the secret. So as soon as the loop ends, you know. There we go. Let me put a blank line here. As soon as the loop ends, you know that you won. The only way the loop can end is if you guess the secret number.
Right.
That's fine. All right, so that's that. This is one way of doing it, and this is great. It just cuts off by doing it this way. You get rid of one test. So if you see you're doing guess not equal to secret, you also have if guess equals secret. So you have one of those tests is unnecessary. So you had in here guess not equal to secret. You also had an if statement if guess equals secret. So
well, it's implied that the guess would equal secret if it ran through everything, is what you're saying, right? Okay.
Yes. If you get out of the loop, then you had to have guessed the secret number. Okay.
Right.
So
Okay.
7.
The reason I put that in
I'm sorry?
The reason I put that in is because I noticed that if you typed in the right answer, it didn't do anything. And so I think, and that's why that extra condition at the end. Because we had a condition to print everything else, but we didn't have a condition to print you won.
Yes, that's true. Well, we did have a condition to print. We said if guess equals secret. Anyway, this works much nicer because we got rid of we had an unnecessary condition. Because we were testing for guess equal to secret, and we're also testing for guess not equal to secret in our while condition. So there's no reason to have both tests, guess equal to secret and guess not equal to secret. Do I have an undo button on this thing? Here, I'll show you what I'm talking about.
So which part are we supposed to take out now?
I'm sorry?
Which part are we supposed to take out now?
You're not supposed to take anything. Okay, here, you can do it like this. What we did, we took the print statement out of the function. I mean, out of the while loop. Or the print you win out of the while loop. Again, because what we had before was while guess is not equal to secret, we also had in here, we had this if statement in here. We had if guess equals secret, and I put the parentheses in again, naturally. Okay, there we go. Then we were writing, put this back again. Cut, paste, indent. Tab, whatever. Okay. So, do you see what's wrong? Notice that you have this a test, guess equal to secret. You also have another test, guess not equal to secret. So one of those tests is unnecessary. All right, so I've done something here that, oh my God.
But I have a question though. So we don't need to print the test, but we still need to print to win if this is equal to secret, because otherwise it's not going to print.
Yes.
He's saying he doesn't, sorry.
All right. what I'm saying is that you don't need both conditions, because when the while condition is false, is false, it means guess is equal to secret, the loop ends, and you can print you win after the loop ends. This condition is unnecessary. Here, let's do both.
So which condition? Like I can't see what
This
you're saying.
condition, guess equal to secret, is unnecessary.
We need to remember that.
Let's do it. Let's do it out. Let me just copy this, and we'll compare the two of them. Copy. We'll paste this in here. Let me see if I can get this in here. Oh God, I'm in the wrong file. Oh my God. All right, here we go. This is the file I want, I think. Oh, there we go. Okay. Now, I'm going to take this out. Take this condition out. I'll delete this condition. I'll take this print statement. Cut that out. Cut. I'll go down here. New line, new line. Get rid of the indent. There. It's indented. Okay, good. Let's move this up a little bit to avoid confusion. All right. Now, if you compare the two loops, they're going to give you the same output. Well, let's make the correction you suggested, or one of you suggested. I'll cut this out. Cut. Paste this in here. Paste. Okay, let's put some space in here. There we go. All right. You'll notice that the first version of the game has 1, 2, 3, 4 conditions. Here's a condition. Here's a condition. Here's a condition. Here's another condition. This one has only 3 conditions. 1, 2, and 3. All right.
What's that third one? What's the third one?
Guess less than secret. Right here. Guess less than the first one is
What's
guess.
below that?
I'm sorry?
So what's guess is equal to the what's below it? Guess is equal to integer.
That's another
of
input statement. It's another input statement. Like that.
Okay.
No, we could actually be even more clever if you'd like. But I think this is about as clever as we're going to get in the next 6 minutes. So we'll do something clever next time. But let's compare the two.
The print has to be under. Okay.
The print is printing after the loop ends. It says print you win. That's no longer part of the while loop. See, the only way the loop can end is if guess equals secret.
Professor?
Yes.
I worked on this one, and couldn't you just assign another like variable and then just have it add one every time you run the while through the while statement? So I was able to get it with only using like 15 lines of code.
All right, that'll work, of course. But what we're going to do eventually is we'll only give the person 7 guesses. If you do it your way and simply just I assume you simply keep guessing a number until you get the right answer.
Well, every time it loops through, it adds another number to this unassigned variable. So I started off at 0, and then every time it runs through, it adds 1. And so the while will only keep going while that variable that adds 1 every time is under 7.
So you're giving the user just 7 guesses?
Yes.
Okay. We haven't incorporated that into our program yet, but that's coming up. Right now, yeah, that works. That's fine. You want 7. That's a more complicated condition. Well, you're saying that you're going to keep guessing while you haven't guessed the secret number and you haven't made 7 wrong guesses yet, is basically what your solution is. That's a little bit more advanced for us. We haven't gotten there. So yeah, but you're absolutely correct. The loop will never run more than 7 times. The loop will never execute more than 7 times. Let's see. Let's just stop at this point. We have 4 minutes official time. Some people, okay, but 4 minutes of official time. So how are we, does anyone not understand this final version, which I will send to you soonest? How are we doing? Going once, going twice, so everyone understands what's going on here.
All good.
Everyone's
Yes.
happy with this. Nobody's
Yeah.
happy. All right, I think this is as far as we're going to go tonight. I think we did a nice job with some simple conditions, and we got through complicated programs, and this indent stuff we got worked out. At least we understand a little bit better. So I think we made a lot of progress. Again, this is as far as they wanted you to go. Well, I'm actually taking some this, by the way, the problem we just did was from your Visual Basic textbook that you would have used had we used Visual Basic. So, so we are getting the same stuff and possibly a little bit more of the same stuff because we're going to go further than we would have gone in Visual Basic. Okay. So if you understood this, that's good. I'm going to call it a night unless you have some questions for me.
When will you have office hours again?
Let's do Thursday, and
Like tomorrow?
Is Thursday tomorrow?
Tomorrow.
Sure it is.
Can we
What time though?
Sunday okay again? Can we do
4 to
Sunday?
6 in the evening. How's 4 to 6? I got to do this for all my classes though.
I
How
have
does
class on Thursday. I won't be able to.
8 to 10 at night, perhaps?
What about Sunday? Is Sunday good
Sunday I'm
for
always
you?
ready.
And
I
for
can always go on Sunday. I want to do more days than Sunday.
I'm free on
Okay.
Monday mornings and Friday mornings. Anyone else?
I'm not free on Friday mornings. I have a class, but I am free Monday morning. The day, pardon me. The days that I am free are Sunday, Monday, Tuesday, and Thursday. Sunday, Monday, Tuesday, and Thursday, yes. I have class on Friday, Saturday, and Wednesday.
I'm free Sunday and Monday. Anyone else?
So Sunday and Monday are fine. What hours are you Sunday and Mondaying?
I'm free
Preferably
Sunday
morning, but
and
not
Monday I'm not.
All right, one person at a time.
Okay.
Okay, Mr. Kittis, when are you free on Monday?
I'm not free at all on Monday, but I'm free on Sunday all day.
Sunday, okay, Sunday's fine with me. Sunday 2 to 6. Okay. Mr. Pinas? I want to say Penthouse, but I know that's correct, not correct.
Oh yeah, any day is fine.
Okay, so okay. Sunday 2 to 6 is still good for everyone. Mr. Chan? No, Mr. Chan. Mr. Kim?
That's
people
me.
putting them
Not a
in
mister
the
again.
I'm very sorry.
It's okay. I think it would be easier, Professor, if you just set a day and we will adapt because there's 12/13 of us and there's no way that you're going to be able to coordinate with all of us and all of us try to pick a day. So I think it's best that you just choose a day and then we will find a way to make it.
Sunday 2 to 6?
Sure.
Perfect.
There's people in the chat that are putting 2 to 6 also on for
Say
that.
that once more?
There's people putting their times in the chat, and one of the persons did write 2 to 6 was fine for them on Sunday.
Yes.
Oh, good.
Also, I think you should call everybody Mrs. from now on.
I'm going to say I should refer to everyone as it.
No, Mrs. is
It
great,
is. It is gender neutral. Well, Mrs. is not gender neutral. It is.
but it's funnier.
Oh, yes.
Okay, so Sunday it is. Thank you.
All right. Okay, no one else is coming, Mr. God, I don't want. Wong Sawat? All right, well, okay, no one's talking. That's fine with me. So I can do Sunday. Let's see, Sunday 2 to 6. Monday. I think I don't know how many people are working, but Monday 2 to 6, if you don't mind.
I can't do the afternoon. I can do the morning of Monday.
Okay, let's see. Monday 10 to okay. Okay, Monday 10 to 2. How's that?
Cool.
Sunday 2 to 6, Monday 10 to 2. All right. I guess Thursday. You know, on Thursdays I wake up at 2:30 in the morning. So actually every
What?
Tuesday, Thursday, and Saturday I'm up at 3.
Why?
That's a secret. Let's see. My brother has dialysis. I have to help him go to dialysis.
Oh, sorry to hear that.
At any rate, let's see. Well, okay.
Will you post a link to the meeting for the office hours?
I'm going to put an announcement for the office hours, 2 to 6 on Sunday, Monday 10 to 12.
Thank you.
So I'll do that for all my classes, and if they want some more, we can give them some more. All righty. I hope this went well for everyone. I'm glad you all asked lots of questions, and so we got all this stuff about the indenting and about the conditions knocked out, and so on and so forth. You know something? I don't know if I need these parentheses around my while thing. I don't know that I need parentheses here. Let's see. I'll put a space, and in the language that I know, you always use parentheses for stuff. But let's see about this guy. Invalid syntax. If guess equals. Let's put the parentheses back in and see if we get the same error.
I took mine out and it worked fine.
Oh, then I have another mistake somewhere.
Professor?
Yes.
Right on top of the second min and max where it says seed, it's right after the print from the last one. Is that supposed to be there?
Oh, this. Yes. No, it's not supposed to be there. That should be on a separate line. Yeah, that should be indented. Okay. All right, let's try it again. I will probably use parentheses. Oh, God. All right, so what's wrong here? Guess equals int input. If guess equals secret, so what are we doing wrong here? Let's see. This will be the last mystery. While guess is not equal to secret, good. If guess is greater than secret, print. If guess is less than secret, print. Guess equals, that seems to be, that's, oh, I'm missing a parentheses. There we go. All right, let's try it again. Okay, at least I got another error. No, an error in another place.
Oh, it's the same parentheses problem.
Thank you again. All right, let's hit it again. Okay, good. Enter a number.
Yay.
Okay. All right, that's fine. Okay, I'll upload this to you guys, and I'll post my office hours on an announcement so everyone can come. Let's save this.
And the assignment that you assigned, you said is it due tonight?
No, well, we can't really do it yet.
Oh, I see.
I don't. Now let me look at it. I don't remember if we got enough. I don't remember if we got enough far enough to do it. But if okay, let's check. First, let's save this, and let's check the assignment. Okay. The only problem here. Yeah, the border. Okay, let's move that. There we go. Okay, let's close this up. Close this up. Your probe is still running. Do you want to kill it? Yes. All right. All righty. Let's close, save that. All right, let's see what the assignment is then.
So this is what I think it's Gabriel who had mentioned it before, is that it's essentially the same thing that we had just been working on with the guessing of the numbers, but we just have to limit it to 7 tries.
Right, that's what it was. Yes, let's go and look at that. Let's see if this is within our powers. And let's see. Okay, now my problem is I cannot find where to get stuff. All right, let's try this again. All right, let's see. I'm in the same place. There might be summer school.
Yeah, summer class are going to be online also.
This is, oh my God. I can't, there, no, that's online faculty assistance. No. No, there it is, great. Okay, here we go. Let's try it again. And again, here we are. Again. And again. And here we are. And assignments. Okay, so this is classwork 8, problem 1. Oh, it's available until May 3rd. Okay, write a program that generates a random number between 1 and 100 and ask the user to guess what the number is. One moment. Okay. And write a program that generates a random number between 1 and 100 and asks the user to guess what the number is. The user has 7 guesses to guess the number. If the user's guess is higher than the random, okay, that's too high, try again, blah, 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 blah. If the user makes 7 wrong guesses in the program play, you lose, and you display the random number. Okay, I think you could do this. I think you can do it. So let's try this. You have quite a bit of time to do it. I'm going to give you a homework assignment in a couple of days. Probably won't be as hard as this. But I do have to throw some loops at you. Maybe I'll give you 2 problems, one with a for loop and one with a while loop. And I'll have to think about that for a bit. And okay, so that's correct. Okay, it's published, so we're fine there. So I got to save it. And away we go. Okay, pardon me. Are there any questions about anything? You want to have it, okay, you're going to have a final test in Python, but that's not coming up until June. So you don't have any tests to worry about. Alrighty, I can't think of anything else to say to you.
Great. Thank you, Professor.
You're very welcome. Thank you for correcting me as to who you were.
So the 7 guesses, that's where I have to go back to the other programming and create numbers.
You have to create another variable called guess count. And what's going to be hard to do, because see now, there's 2 ways that your loop can end. You can either guess the secret number, or you can make 7 wrong guesses. But see how you handle that. When you do the solution, I hope my solution will make a little bit more sense than yours, because I have a feeling you're going to have a lot of, I forgot to tell you one thing. The way you get out of a loop, if you don't want to use a loop condition, is with a break statement. Here, let's knock that one out. I didn't cover break statements, but you're going to need it. I'll tell you what, why don't you research break statements, and if you have a problem with it, let me try to get Python up here. Oh my God, here. All right. Okay, let's do this one. All right, so I'm going to show you a break statement. All right, okay, let's get, what are these? I'm going to do a new one. File, new, file. All right, here we go. So I just do I equals 3 while true. I equals I plus 1. We'll just do a print I. Let's do print I. All right. Print I like this. Now, as you look at it, let me run the thing. And if you look at it right here, run. It's going to go on forever. Oh, I got to save it again. Infinite loop. Infinite loop. There we go. Run. Invalid syntax. Okay, that's, as I say, I'm going to keep doing that forever. One more time. Run. Okay. Oh, it's okay. It's capital T, not lowercase t. All right. I think that's correct. I guess not. Maybe not. Okay, there we have an infinite loop. It's never going to end. It'll eventually end when it generates a number that's too big to be stored in an integer, and it'll crash. But that's about 4 billion. And so I don't want to wait that long. Okay, so what you do is this. You want to stop when I is equal to 7. If I equals 7, colon, break. And that is a break statement. One moment. And there it breaks after, as soon as I equals 7, we get out. So you might use a break statement to get out of your loops if you're still a little bit uncomfortable with while conditions to get out of loops. Now I'll save this one too, and I will upload this too as well. File, save as, and let me find my stuff. Hold on, my files. There we go. 136. Oh, wrong class. Sorry. 103. Oh, Oh, I'm gonna, excuse me, 1 second. All right, here we go, notes. And that would go in here. I think I saved it. Let's try it again. File, save as. And this is infinite loop. I did save it, good. Okay, I will put this in a separate file called programs or something, and I'll just put in another announcement. Okay, so I'm actually, let me just try this here. Actually, something I actually did not record this session. I'm supposed to do that as soon as the thing starts, and I did not do that. So you missed another great moment. All right, so if you have no questions and I have no answers, or maybe it is recording.
It's recording. See, it's recording anyway.
Hmm?
It says on the top right, top left of my screen, it's recording.
Oh, good. Well, all right. So, okay. Well, then we're done then?
Yes, thank you.
Okay, then I'm going to log off.
Have a good night.
Stop sharing. And I will see you later. And I got to post our office hours to all my classes. And we go on from there. Stop sharing. So I'll say good night to you. It is
Good night.
There you are. Is that Ohio?
Yes.
Okay. Someone's watching television.
Sorry, I'm watching Friends.
Oh, that's okay. I'm just kidding. Let's see. Stop recording. So I'm going to do that. All right. Stop recording. Oh, in meeting. Okay. Good night. I'm going to click in meeting, and that'll be it.
Good night.
Good night.